greenhouse gas emissions. Oh, okay. Yeah, so we are assessing the life cycle greenhouse gas emissions of low carbon powertrains for medium duty urban delivery trucks. Specifically, we are presenting the results for the case of Singapore, which is a dense city state in Southeast Asia. So let's begin. So to start, road freight provides an essential service for our society and economy. It is a key sector to decarbonize because almost all road freight runs on diesel and the sector is growing rapidly. In our case study of Singapore, goods vehicles make up the majority or 76% of diesel fueled vehicles. And even though diesel vehicles only make up 19% of the road vehicle fleet, they are responsible for 63% of greenhouse gas emissions from land transport. So to provide a better picture of goods vehicles in Singapore, here's the distribution of heavy and very heavy goods vehicles by type and maximum laden weight. So as we can see, there's a large variety of vehicle types across the weight spectrum, and each vehicle type serves a unique purpose. On the lighter end, we have the vans, lorries, and refrigerated vehicles. Now, these carry general cargo or goods that require a cold chain like food. And on the heavier end of the spectrum, we have the tipper trucks, which carry bulk materials like sand and gravel for construction. At the heaviest end, we have the prime movers, which haul very heavy cargo like containers or even other vehicles. There's also a variety of specialized vehicles shown here as others. These include cement mixers, cranes, and garbage trucks, etc. So in our study, we are focusing on the lighter segment of the heavy goods vehicles in the 3.5 to 7 ton range, which makes up the largest proportion of HGVs in Singapore. Now, there are several promising options for low carbon vehicle technologies. For example, here we see a battery electric truck and a hydrogen fuel cell truck put forth by Mitsubishi. In addition, like several other countries, Singapore has announced a policy goal to phase out internal combustion engine vehicles by 2040. However, the high mileages and payloads experienced by medium and heavy-duty commercial trucks make decarbonization a challenge. Furthermore, the life cycle impacts of alternative fuels and powertrains are context-specific and not fully understood. In fact, in our review of the literature, we found that there are a lack of studies assessing the impacts of medium and heavy-duty hydrogen fuel cell trucks, and we think this is likely due to the early stage of technological development. So this brings us to the aim and scope of our study, which is to compare the life cycle greenhouse gas emissions of low-carbon powertrains for medium-duty urban delivery trucks. So in addition to the conventional diesel engines, we are considering alternative powertrains like hybrid diesel, battery electric, and hydrogen fuel cells. We are focusing on the medium-duty urban delivery trucks with a gross vehicle weight rating of between 3.5 to 7 tons, which corresponds to a Class 3 or Class 4 vehicle in the United States or an N2 truck in the European Union. We are conducting our study in the context of Singapore, which is a dense urban environment with limited renewable energy availability. We are defining our functional unit as moving 1 ton of goods by 1 kilometer, and so the life cycle GHG emissions will be reported on a per ton kilometer basis. The data, parameters, and processes used in this study were obtained from existing LCA databases such as GREET or from the literature and previous LCA studies. Where available, we also make use of local data to understand the life cycle impacts in our study context. So here we see the system boundary and processes for our study. There are 2 main products involved here, the fuel and the vehicle. In the well-to-tank portion of the fuel cycle on the left, we consider the production and transportation of feedstock, which leads to the production and distribution of fuels. The fuels in this study are diesel, electricity, and hydrogen. In the vehicle cycle on the right, we consider the production and transportation of material for assembling the vehicle. This is reflected in the key vehicle components such as the chassis, batteries, fuel cell unit, and hydrogen tank. The vehicle and fuel cycle then come together in the vehicle use and maintenance stage, which also corresponds to the tank to wheel portion of the fuel cycle. And finally, we consider vehicle disposal and recycling where applicable. So for the vehicle cycle, we focus on a common heavy goods vehicle model in Singapore. For a fair comparison between the powertrains, we selected equivalent models for each powertrain with similar power output and performance. We also set the same absolute payloads across the vehicles when modeling energy consumption. The GHG emissions or credits from manufacturing or recycling the key vehicle components were obtained from the literature. Component replacements were calculated with component lifetimes and usage intensity, and these range from between 2,000 to 5,000 cycles for the batteries and around 19,000 operating hours for the fuel cell unit. Now, in modeling the fuel cycle, we surveyed the energy landscape in Singapore and considered how energy is supplied and in what form. We start with the conventional diesel fuel, which is produced from crude oil and refined. So in 2019, a vast majority, or about 96% of electricity in Singapore was generated from natural gas using combined cycle gas turbines. A small proportion of electricity is produced from coal and petroleum products and other sources like waste to energy plants, biomass, and solar. We now bring attention to natural gas supply, which is the main fuel for electricity production. Natural gas is either transported to Singapore via pipelines from neighboring countries or by ships in the liquefied form. In 2019, about 65% of natural gas was piped via undersea pipelines, around 500 to 600 kilometers long. The remaining 35% was shipped as liquefied natural gas, which arrives in tankers as shown in the image below. Now, since most electricity is already generated from natural gas, the most immediate pathway for producing hydrogen in Singapore would be with steam methane reforming. In steam methane reforming, natural gas or methane is reacted with water to form carbon dioxide and hydrogen. Hydrogen produced by this method is known as grey hydrogen, as CO2 is still generated in the process. After the hydrogen is produced, we considered two further pathways for distribution. One is where hydrogen is compressed and distributed in the gaseous state, and another where it is compressed and liquefied. Even though local solar output is unlikely to meet Singapore's total energy demand, we still considered solar power, electricity, and hydrogen production via solar electrolysis to illustrate the full potential of a decarbonized energy supply. Finally, in all pathways, we accounted for the losses from transmission, distribution, charging, and refueling, and we use the LCA database GREET as our main data source, along with data from our local energy authority. All right, moving on to the use phase. Here we are interested in understanding the intensity and extent to which the vehicle is used during its lifetime. There are three components in characterizing the use phase. Firstly, we construct a drive cycle to represent the typical usage patterns of the truck in our study. Secondly, we use energy consumption models to translate the usage pattern into energy or fuel use. And finally, we estimate the lifetime mileage of vehicles in our study context to represent the extent of vehicle use during its lifetime. So to represent local driving activity, we constructed a drive cycle based on speed data collected from 5 trucks in 2015. These trucks mostly did fashion and retail deliveries. Speed data was collected via the onboard diagnostics or OBD port as shown in the two images here above. With the speed data, we used existing drive cycle construction methods to form a drive cycle as shown in the image below. As we can see, a long idling time was observed in the constructed drive cycle, which likely corresponds to the loading and unloading activities of the truck. We then modeled the energy consumption of the vehicles over the constructed drive cycle. The energy consumption models calculate power demand at the wheels based on forces acting on a vehicle, as shown in the diagram on the right. Now, these forces depend on operating characteristics such as the speed and acceleration, and vehicle parameters such as mass. We also took into account energy recovery systems, which are typically present for hybrid BEV and FCV powertrains. Using these models, we estimated the tank-to-wheel energy consumption per ton kilometer at various payload settings over the constructed drive cycle. This is shown on the chart on the bottom right, which shows the case for a 1.4 ton payload, which is 50% of the maximum payload capacity of the conventional diesel vehicle. Finally, we estimate vehicle lifetime mileage by multiplying the daily mileage with the vehicle lifetimes observed from local data. Daily mileages were obtained from GPS traces collected from a sample of 33 medium-duty commercial trucks during the period of 2017 and 2018. Vehicle lifetimes were estimated using local age distribution data for goods vehicles. As we can see in the chart on the right, we observed 3 peaks at 10, 15, and 20 years, where more vehicles are likely to be scrapped. These peaks are an effect of Singapore's vehicle ownership policy, in which a certificate of entitlement is due for renewal when a vehicle reaches 10 or 15 years of age. Some vehicle owners might choose not to renew the certificate and scrap the vehicle instead. In addition, there's a statutory age limit of 20 years for goods vehicles. Bringing together the vehicle and fuel cycle and the use phase, we arrive at the results of our study. The chart here shows the life cycle GHG emissions per ton kilometer for the different vehicles and fuel production pathways. We also show the contributions of the different life cycle stages, such as the direct emissions in the use phase and the fuel and vehicle production. The error bars show the range of uncertainty in the emissions from the minimum to the maximum values, while the black dots represent the average values. Now, comparing between the fuel production pathways, we conclude that decarbonizing the fuel cycle is critical. This is because energy use in the use phase accounts for the bulk, or more than 75% of the life cycle GHG emissions for the current fossil-based fuel production methods. We also conducted the analysis for different payload settings at 25% payload and 75% payload. Although there are some differences in the life cycle GHG emissions, we found that the overall relative positions of the alternatives remain consistent across the payloads. Okay, let us now compare the performance of specific alternatives. So if we just consider fossil-based fuel production methods, diesel hybrids and FCVs using gaseous hydrogen via steam methane reforming are advantageous and provide GHG reductions across payloads. These reductions range from 9 to 10% for diesel hybrids and between 16 to 27% for FCVs. However, BEVs powered by Singapore's 2019 electricity mix had mixed results in terms of GHG emissions. Considering the range of uncertainty, the results range from a 15% reduction at 75% payload to a 9% increase at 25% payload. The emissions uncertainties mostly come from uncertainties in battery production and replacement intervals. Lastly, we found that FCVs running on liquid hydrogen produced via steam methane reforming can lead to higher emissions, up to 25% more than conventional diesel at the highest payload setting. This is largely due to the energy required to both compress and liquefy hydrogen. So the results so far were based on a fixed value of average lifetime mileage that we obtained previously. In addition, we are also interested in the life cycle GHG emissions as lifetime mileage varies. We consider the break-even mileage for the diesel hybrid, BEV on Singapore's 2019 electricity mix, and for FCVs on gaseous hydrogen via steam methane reforming. So to define, the break-even mileage is the distance that a vehicle has to cover in order to have lower life cycle GHG emissions compared to the conventional diesel vehicle. In general, the average break-even mileages are much lower than the average lifetime mileage, with diesel hybrids having the lowest, followed by FCVs on gaseous hydrogen via SMR and BEVs on the current electricity mix. When considering the range of uncertainty, the BEV only provides a slight advantage over conventional diesel, even up to high lifetime mileages of 1 million kilometers. Finally, we observed a noticeable effect of the periodic battery replacements on the life cycle GHG emissions of BEVs. Going further, if we cross the distribution of daily mileages and vehicle lifetimes, we can get a sense of the distribution of possible lifetime mileages that vehicles might experience. Now, if we plot the break-even mileages that we obtained previously, we see that for the diesel hybrid and FCV with gaseous hydrogen via SMR, the lifetime mileages are almost always higher than the average break-even mileage. However, for the BEV on Singapore's current electricity mix, a sizable proportion, more than 40%, of the lifetime mileages will fall below the average break-even mileage. What this suggests is that we need to ensure vehicles remain in service for long enough so that we can reap the benefits of switching to other fuels and powertrains. Overall, we can conclude that decarbonizing upstream vehicle production is critical. But in the case of limited renewable energy availability, like countries such as Singapore, FCVs running on gaseous hydrogen via SMR and diesel hybrids are potential options. Comparing between the two, on the one hand, FCVs running on gaseous hydrogen via SMR can provide up to a 27% reduction in GHG emissions, but implementing them on a large scale requires infrastructure modifications and market maturity. On the other hand, diesel hybrids can only provide modest GHG productions, but are still clearly advantageous when compared to conventional diesel. And currently, they have less uncertainty and barriers to adoption compared to FCVs. Moving on, as observed in the analysis of break-even mileages, policies could be used to prevent vehicles from reaching the end of life before GHG reductions are achieved. Some ways this could be done with minimum mileage requirements for clean vehicle subsidies or by taxing vehicles that are scrapped early. Secondly, investments in cleaner technologies for heavy vehicles should be continued because the technologies are still at the early stages of development, which then gives rise to large uncertainties in producing and replacing the key powertrain components. Local technology pilots are one way to better understand the performance and impacts of these new technologies. And of course, there are several opportunities for future work to expand the scope of this study. For one, a localized prospective assessment can be considered, which would account for future developments in the energy sector, such as in carbon capture and storage and power grid interconnections. These developments could potentially reduce the carbon intensity of electricity and hydrogen, which will reduce the GHG emissions from BEVs and FCVs. While our current study focuses on individual vehicles, a similar analysis can be conducted for specific vehicle use cases or even fleet-level assessments. This would account for the unique operational dynamics and requirements encountered in specialized domains. Finally, the study scope could be expanded to cover other environmental impact categories such as pollution and resource depletion, life cycle costs, or charging and refueling infrastructure. All right, we have come to the end of the presentation. Thank you for your attention, and any questions and comments are welcome.
Yeah, thank you so much for this interesting presentation. Yeah, if there is any question, please unmute yourself. There is not any question in the chat box. So if anybody wants to add something, we have about 6 minutes. So please go ahead.
But this is Kockelman. I know when I was in Singapore, they're not supportive of BEVs. It was crazy trying to talk to the transportation and housing people about getting charging stations and cords. And so yeah, to be a BEV owner was so expensive right now. I think there's only a few Teslas on the entire island. Is that true?
Yes, that is true, but in terms of like the policies and like the government push, it seems to be changing. So recently they announced that they're going to roll out many more charging stations, and they also tweak the vehicle taxes to make it, EVs more palatable for people to buy. Yeah, so definitely it is changing, although it will take some time because vehicle renewal can't be done instantly. Vehicles typically have a 10-year lifetime in Singapore, so we've got to be a bit patient. Yeah.
Thank you. I wonder, are you like Europe that you have 240 volt outlets in your homes and businesses? Here in the US, we just have 120. So we have to upgrade our garages to charge our BEV.
Oh, yeah. In Singapore, yeah, it's 240 volts. I'm not too sure about charging infrastructure, whether it's similar to the household ones, because here in Singapore, we don't have many standalone like houses, like private houses. Most people live in high-rise apartment blocks. So charging infrastructure would then have to be in the shared parking lot, which I believe would make things easier in terms of rolling out charging infrastructure, because it will be shared by multiple users.
Right. But they
but I
don't
didn't know
have
about
much
the
energy.
voltage. Okay.
Right.
Mm-hmm.
But those standalone parking garages that you often have do not have much power delivery because they never expected to need more than lighting at night. And so,
correct.
Yeah, the housing authority people told me that they would need to upgrade. If it was the whole building, they'd be fine. They could absorb that load, but not on the parking garages, many of them, unless they're already, co-sited with, like underneath the housing units.
Yeah. So quite interestingly, Singapore's power company, I think Singapore Power, so they do the power infrastructure for like basically power supply for the entire country. So they are also rolling out charging stations. So I guess it's part of the expertise, and it would help to make things easier. So that's for the passenger vehicle side. In terms of freight electric vehicles, we still don't have that many. It's still quite uncertain whether logistics companies would want to have charging infrastructure in their own premises maintained by themselves, or whether it would be better for them to rely on the public infrastructure. So I think that remains to be seen.
Thank you.
Thank you.
Yeah, thank you very much. I assume there is no more questions. So I think we'll go ahead with the second presentation. Thank you very much.
Thank you.
All right, so Our second presentation title is Innovations Impacting the Future of Transportation, an overview of connected, automated, shared, and electric technology, which will be presented by Huang. Huang is a postdoctorate research fellow. He received his PhD degree in transportation engineering at Monash University, Australia in 2020. He holds double master degrees at Monash University and Southeast University, China. His research interests are network planning and operation strategies designed for shared mobilities. It focuses on advanced mathematical optimization techniques to solve difficult transportation problems. At UT Austin, he has contributed to anticipating and modeling the impacts of various technological and other changes on travel choices and traffic conditions under an NSF Industry University Cooperative Research Project. So I think we have Kai here. Is that right?
Yes.
Okay.
Can you give me okay. It's
right.
Okay.
Yeah, please go ahead and share.
Okay. It's okay?
Yes, all good. Yeah, I can see your screen.
Okay. Good morning, everyone. I'm Huang. I'm the postdoc research fellow at the University of Texas at Austin with the supervisor of Professor Kockelman. Today, the presentation is an introduction about the innovations impacting the future transportation. We will review the connected, automated, shared, and electric technologies. And in this work, we will firstly have a little review of the related technologies, and then we make a survey to study people's attitudes to the new technologies. So this study reviews the transportation technologies, services, policies is to predict the US cities and regions in the future. And totally about 15 innovations are revealed in the keywords of connected, automated, shared, and electric. We call it the CASE, C-A-S-E here. Like the shared technologies, we will review the car sharing, ride sharing. If we use the autonomous vehicles, we call it the SAV, shared autonomous vehicles. And for the electric vehicles, we will compare the battery electrical, hybrid electrical, and fuel cell electrical with traditional gasoline vehicles. And then the electric truck and electric bus will be revealed. For the connected and automated technologies, we will reveal some new innovations like the remote control technologies and the drone delivery. So let's have a look at the details. The first one is vehicle-to-pedestrian communication systems. Like the first figure, the left one, they will have some devices in the vehicles. And mobile phone application in people's hand. When the distance between pedestrian and the vehicle is closed, pedestrians and drivers will get the alarm information and try to stop to avoid the crash. So for the, let's have a look at the exciting studies. For the V2P communication systems, most the paper focus on the information communication technologies development, and some studies the information notice method. We can find some applications like the LED display on the vehicle and the laser projections that the people can get find the information before the car or on the car. And the next way is the remote control technology. In some complex situation, like the bad weather, the driver can remotely control his vehicle to pick up him. And for the studies, the delay time caused by the human response and information communications is a hot research topic. We can see some application like the remote control vehicle organized by the SLIC motor or the Huawei technology. And next is automated technology. The first one is the automated guided vehicle based on intelligent parking system, like the first figure. The AGV can help the driver to park the vehicle in the parking building. The drivers do not need in the car. This is why the time of parking and the frequency of parking will be better if we use AGV. And the second one is vehicle platinum formation. It's widely used in the truck fleet. The foreign vehicles of drivers of foreign vehicles do not need always drive the vehicle. They can have the relax and just keep the same distance and speed with the leader vehicle. And the last is drone delivery. Some goods, your goods can be delivered by the drone in the air. So let's have a look at the studies. For the AGV-based intelligent parking, some studies focus on the AGV schedule optimization or the AGV route optimization. Some new startup companies are exploring those technologies, like the RAY and the Parking Plus. They provide such a service for the intelligent parking buildings. For the vehicle platinum, studies focus on the formation control method, like the leader-follower and the behavior-based virtual structure approaches. Also, such study focus on the traffic flow theory among the vehicle fleet. Because some traditional manufacturers are studying those technologies, like the Daimler Platinum, which is having the test, and the Volvo truck use platinum technologies in some vehicles. For the drone delivery, some studies focus on the drone delivery schedule optimization or the route optimization. Some widely used technologies can be found in DHL. They help to deliver those goods, some goods. And for the shared technologies, first part is new shared mobilities, like the car sharing, ride sharing, and the bike sharing. And the people do not, for the car sharing and the bike sharing, people should drive the vehicle or bike's car, bike's cycle. And for the ride sharing, it means people can share the vehicle with other guys. If we use, in the future, use the autonomous vehicles, we can call it the shared autonomous vehicles, SAV fleet. And some traditional shared mobilities, like the carpooling and the demand responsive buses, both of them will review them. For the car sharing, most studies divide those topics into two levels. The upper level is the long-term decisions to decide the strategic planning, and the lower level is a real-time decision, to decide the vehicle movement and the vehicle relocation. Some considering companies like Zipcar, Car2Go are popular. It's easy to be found in Australia, Europe, or America. For the ride sharing, sometimes we call it the taxi sharing. It focuses on the passenger matching routing choice. Also, for the travel pricing is important topic. It's to decide who and how will people like to use the ride sharing based on the price setting. And we can find them in some or some company like Uber, Lyft shared, and Didi share in China. For the SAV, because it had not been widely used due to the technology, so the activated simulation is popular, like the simulations in the Austin area, conducted by the group, by our group, the Professor Kockelman's group, is widely accepted. And for the bike sharing, most of the study focus on the people's influence factors that decide their mode choice. The bike sharing can be divided into the doctor and the doctor's bike sharing. In Melbourne, it's a doctor that people should pick up or return vehicle in the fixed station. But in Singapore, it's popular to see the doctor's bike sharing. People can pick up and drop off it anywhere you want. For the carpooling, some study focus on the travel behavior analysis and the passenger vehicle allocation. For the demand responsive buses, it's a challenge to decide the real-time vehicle routing optimization. Sometimes we call it the real-time VRP problem. And the last is the P2P shared parking. That means you can share your parking with strangers and get some payment. So only a few studies focus on this topic. We can find them focus on the parking space location and the charging strategies because it has no practical cases. So we can just see some smart parking in limited cities. The last is electric technologies. Firstly is the battery. For the electric vehicles, normally we divide them into the battery electric, hybrid electric, and full cell electric, because it's totally different from the traditional vehicles, the gasoline or diesel vehicles. So some studies focus on the life cycle cost, or some focus on the emission compression. We can find, it's easy to find the electric vehicles like Tesla, Toyota, Prius. And for the electric truck, it needs a huge battery capacity. So the battery efficiency and the emission distance is other hot topic. For the electric truck, we can see some applications in Ford and Toyota. The last one is the electric bus. Normally, research focus on how to jointly optimize the fleet size and charge station planning. For the application examples, the BYD manufacturer is popular to have the electric bus. Okay, the above shows the literature review about in the case CSE topic. And then to have a survey of people's attitudes to the new technologies, we have a survey in April of this year. 1,000 Americans are collected. The response time is about 35 minutes. Before I have the survey, we set the sample target based on the gender, age, education, and the location. And then after get the data, we weight it again based on the national household travel survey. Finally, we compare it with another survey conducted about 4 years ago in 2017. It's also a case survey. We collected 1,300 people. It shows the two surveys. We will compare. We said same questions in two survey and to compare people's change before and after the COVID-19. Firstly, shows the next vehicle type. We can find the before and after 4 years, the numbers do not change a lot, but the people who are going to buy a new vehicle increased over 10%, and the people want to buy the used vehicle drop over 10%. The second shows the next vehicle type. In those years, with the development of the electrical technologies, so people want to buy the gasoline or diesel vehicles drop a lot, over 20%. But people who are going to buy the electric vehicles, no matter what, hybrid electric, plug-in hybrid electric, or full electric vehicles increased a lot, over 20%. Here shows the next vehicle buy plan in different years, maybe because of the bad economic situation. People who are going to buy a new vehicle in the next 1 or 2 years drop a lot, and people who want to buy a vehicle 10 years later or now have no plan to buy a vehicle increase a lot, about 4 or 5%. And then we have the comparative analysis between the current and future scenarios in different vehicle type. Also, people want to buy the gas and diesel vehicles drop about 26%, and buy the hybrid plug-in battery electric vehicle increase a lot, no matter what kind of vehicles, including Cooper, minivan, pickup, or others. Here shows people's we study the people's activities of work, school, or shopping, or personal business, social activities. We can find who want to use the bike or work increased, and people want to drive alone drop a lot, maybe because they want to share a vehicle with other guys or want to use the public transport. Because 4 years ago, the data people want to use ride sharing, taxi, Uber, or Lyft, or electric scooter is very low. But in those years, with the development of the intelligent mobilities, people want to use those technologies increased about 10%. It's a good news. And then the last part is factors impacting people's motor choice. We consider both people's concerns or willingness to use those new term modes. First one is electric vehicles. For those people who do not want to use electric vehicle, the first reason is that the limited battery capacity. And then only a few charging stations is another reason that limited people's willingness to use those electric vehicles. Third reason is the long charge time. We know if we charge it needs at least 2 hours to have electric vehicle fully charged. So it's the top 3 reasons that people concerned about the electric vehicle. And for those people who want to use electric vehicle, you can find the first reason is that it can help reduce the air pollution, use EV, and then because electricity costs much less than gasoline vehicles. The third reason is that use the electrical can provide the high levels of comfort than the gasoline vehicles. It's true. The next is the autonomous vehicles. In the autonomous vehicles, people can walk or sleep and with his hand out of the car. Especially for the long distance travel, people can have a break if he use autonomous vehicles. But lots of people are still afraid to use it, maybe because the technologies are not widely accepted. The first reason is that it may cause a traffic crisis. And second one is that the people do not believe such technology that a vehicle can navigate the road under construction, or the road is covered by snow or ice for those complex road situations. The third reason is that buying autonomous vehicles will have a higher vehicle process price. The fourth reason is the unclear responsibility. Is also a big reason because in the new technologies, if we have some traffic crisis, who should be responsible for it? It's the driver or manufacturer. It's not clear. And for those people who want to use autonomous vehicles, they think it's safer than traditional vehicles. The second reason is that it allows younger teenagers and disabled and elderly people to travel alone without others take care. And the third reason is that people can have can work or sleep in the vehicle. The fourth reason is that people who use autonomous vehicles do not need the driver license. Next is bike sharing. The two figures show the doctor and doctorless bike sharing. For the concerns people do not use the bike sharing, the first reason is less safe than other modes. It's true. And some people think it has a long walking distance to pick up or return the rented bikes. The next reason is that when people have the important trips, sometimes it's not easy to find available vehicles, or the vehicle is bricked that people can't use it. The fourth reason is that we can't always have helmets on hand. So it's the reason why people do not use it. And for other people who want to use the bike sharing, they think it's a good exercise to use the bike, to drive, to take a bike. And it's not expensive, it's right. And it will have lower air pollution than a vehicle. And some people want to use it because they can find the vehicles nearby. Some people also believe use the bike sharing can help to reduce road congestion. And people do not need a parking space for his private car if he uses a bike sharing. The next is the microtransit. Sometimes we call it the on-demand minibus or the demand responsive buses. For the first reason that people do not use it, it has a long wait time or the travel distance to pick up other passengers. It's true because in the minibus, there will have some waiting passengers with different origin distances. It's true to have some travel distance. And then if I have some important trips, the minibus can't provide service. The third reason is that long walking distance because sometimes the minibus just can stop in the bus station. For the people who want to use bike sharing, the first reason is that it's not expensive. It's much cheaper than the private car or the taxi. And if you have the commuter trip, you can use it every day. It's very good for those people. And for some people who just have the very low vehicle use frequency, so they do not, they think the minibus is best choice for them.
Sorry to interrupt. We are just running out of time.
I can stop it maybe 2 minutes.
Yeah, it was a question. So we have, I'm not sure if I can pronounce your name correctly. Sorry about that. Giancarlos. So he was asking about this, the questions was stated intention or actual behavior in your questionnaire.
Sorry. Do you mean terrible?
So he mentioned that there is a very large increase in bicycle mode share, 3% to 16%. What are the reasons behind that change? Might there be the method effects or sampling effect?
Yes. For the sample, we did some weight, and it's the SP survey, RP survey. It's RP survey. We give some assumptions and based on the price of the cost and ask people to answer it.
Yeah.
So Giancarlos, I don't think he can see the earlier question, but Kai, when it went from 3% to 16%, that was a big jump in biking. Is that their future intention versus their future intention in 2017?
Sorry, this one?
You would have to keep going back. It's from far back because, you know, these questions can be placed in the chat box at any point. So Giancarlos, do you remember which slide it was?
I think it was in the very beginning that you had those tables, the very long tables that you had the percentage of 20.
That one.
Yes.
The next one.
Go forward. Yes.
That one. So work is 3.1% for bicycle and then 16.3%. So that was a big increase. So I was wondering, is this a stated preference or revealed preference?
It's the preference, state of preference. And we gave some exceptions and set the travel cost and ask people to make a choice what kind of activity will we use, what kind of alternatives will we use if you have such activity. Like if you need to work, use a bike, how much you will pay by work, and drive alone, how much you will pay, and make a choice among them. So finally, so that in this year, in the latest survey conducted in this April, totally 16% of people want to use bike go to work.
Okay, so it's intention then.
Yes.
Okay.
Okay.
Yeah, we'll take another look at this, Giancarlos. Thank you so much.
Okay, thank you.
I think I can stop the presentation because I just have one page. And yeah, I just want have one page. In the conclusion, I can stop it soon.
Yes.
Yes. In this survey, we found the vehicle sharing and electrification is a key pathway to the case development. And to development the mobility as a service, we call it the maas. The car sharing, ride sharing, and carpooling service is very important. And the advanced battery capacity technology and grid is very can provide support for the fleet electrification. And full cell electric vehicles, electric trucks, electric bus will be widely in the future. Lastly, so that the remote control driving and parking will provide controlled environment for the vehicle automation in the future. It's all. You can find our research in our website.
Yeah, thank you very much, Scott. Thanks for your presentation. We might have a little bit of time at the end to get back to this if there is any more question, but I think I should go ahead with the next presentation. Thank you again.
Okay.
All right, so I'm just going to share my screen for introducing the next presenter, which I think he is not here. So the next presentation is Shared Mobility in Post-COVID Era, Facing New Challenges and Opportunities, which is going to be presented by Amirsalar Jafari Gorizi. Amirsalar Jafari Gorizi is a graduate student in Information Technology Management from Shahid Beheshti University in Iran. He is interested in sustainability and preserving the environment, and he tries to make a better future for everyone. So I think I kind of have to, yes, I don't think he is here. So I'm just gonna play his recordings. Right.
Hello, my name is Amirsalar Jafari Gorizi, and today on behalf of my colleagues,
can you see my screen?
We're just seeing the folders right now. Yeah.
But you could see the video, yes? Because I can't see anything else when I share that.
Yeah, when you play the video, you could see it, yeah.
Pardon?
You could see it, I guess.
All right.
So my name is Amirsalar Jafari Gorizi, and today on behalf of my colleagues, I am honored to present our work here. I just wanted to first thank you for organizing this conference, and also thank reviewers for giving us this opportunity to have our work presented in here. And also thank you all for watching me right now. As the title speaks for itself, our study is about finding new challenges that COVID-19 pandemic has presented to shared mobility, more specifically to the sustainability of shared mobility, and also opportunities that we can seize besides facing those challenges. So I'm going to start by explaining the issue and the aim of the study. And we also have an overview of the studies which we had reviewed for our work. And then we move into the method section. And then we jump into the results. And hopefully we can have a brief discussion over results too. So to make sure that we all are on the same page when we are talking about shared mobility here, we use this definition in which core services such as taxis and public transit have also been mentioned. And when we are talking about sustainable mobility, in a nutshell, it means the kind of mobility that meets present generation mobility needs without compromising the future generation's ability to meet their own needs. Every sustainable system has three dimensions, as of social, economic, and environmental. At least it is the most widely accepted modeling of sustainable systems. And we use these three dimensions as a framework for our study too. A demanding part, an inseparable part of working on sustainable development and sustainable systems is that you should always be prepared to face fundamental problems that affect sustainability. And one of those fundamental problems was COVID-19 pandemic that casted serious doubts on the sustainability of shared mobility. And after being hit by this pandemic, we arrived at a stage that striking a balance between personal hygiene care and long-term community preferences was very essential in shared mobility. And our purpose of doing this study was first to investigate impacts of COVID-19 outbreak on the sustainability of shared mobility, and secondly, to give general recommendations within those three dimensions of sustainability. We also have categorized those challenges and opportunities into two levels, as of travel behavior and urban infrastructure. We had two questions in our study about finding potential opportunities and challenges that COVID-19 pandemic has presented to the sustainability of shared mobility, both at the travel behavior level and the urban infrastructure level. In the literature review, we had two subcategories. The first one was the studies done on knowing how the virus spreads and how the disease is being transmitted. And the second one was the studies done on finding COVID-19 impacts on shared mobility. In the first group, we could see that there is a higher possibility of spreading the virus in confined spaces such as shared vehicles. And that makes public transit activities to have a more considerable influence on the epidemic spreading, especially if you are not careful with personal hygiene care, like not wearing a mask. And that is more noticeable in densely populated cities, which makes them to be particularly more vulnerable to viral transmission. Even though travel restrictions have a positive impact on the evolution of the disease, but it's just temporary. And governments should use this period of time to community screening and to have an active contact tracing, and then use the data from contact tracing and individual mobility and also real-time data to better model the spreading of the virus. In second group, there was a study with an argue of remaining lower demand for transport than a counterfactual case of no COVID-19 beyond the year 2020. But hopefully with the current pace of vaccination, we could see that it's not always the case. And also we could see that individual choices are far more important and they seem to be tied to fears of infection. And that actually brings a transformation from the centralized transportation of passengers into more decentralized transportation. And because of that, public transport has been hit severely compared with other transport modes. And there were some reports of significant increases in the average duration of other transport modes, like bike trips and even walking in large cities. So for the purpose of our study, we conducted a three-phase DLC approach composed of both qualitative and quantitative methods. And feedback was obtained from 18 international experts in civil engineering and also shared mobility. There is no consistent and definitive formula on how to use the Delphi method. It's very helpful in predicting. And also there's no best number of phases of the survey. For our survey, we had 3 phases. We also were very careful with validity of the results, both internal and external, and also opinion leaders' domination. We also watched out for reliability and replicability of the results too. We had our third panel classification and composition here. As you can see, we had at first 21 experts, but after phase 1, we only remained with 18 experts. And we also had categorized them into 4 levels based on their level of expertise. You can see also here their background on shared mobility for civil engineering too. So in phase 1, the experts were asked to share their opinions about opportunities and challenges relevant to the impacts of COVID-19 outbreak on those 3 dimensions of sustainability at the travel behavior and urban infrastructure levels. The response rate was 18 out of 21, or 85.71%, and by coding the responses, 35 independent constructs were elicited through the sub-questions that were categorized within 3 dimensions of sustainability. Here you can see questions and all of sub-questions, and also social, economic, and environmental dimensions. You can see that we had 216 answer items for all of sub-questions and only 35 number of expected constructs that are affected by COVID-19. Here's an illustration of the coding process. For example, for construct of lack of trust among passengers, we at first had original text items like crowded trains and buses will be less popular. We interpreted this into avoiding crowded transportation, or we had people will want less crowded transportation, and then we interpreted this into people are not willing to take public transport, and then we had interpreted them to the final contracts as a lack of trust among passengers. The same process was done for all of the other 34 constructs too. Here you can see identified opportunities and their level of applicability. As you can see, we had like social and cultural factors play a more important role. It's only applicable in travel behavior, but we had increasing social equity in having access to transportation, and it's applicable in urban infrastructure level. The same goes for identified challenge. For example, we had environmental issues in urban areas rise. It's applicable in urban infrastructure level, but trivialize environmental issues by people is applicable in travel behavior level. So at phase 2, because all items require prioritization and ranking in order of their importance, we asked our expert panel to give a point by using a 5-point Likert scale. The response rate was 18 out of 18, or 100%, and constructs with mean group value were 4.5 or above were considered the most important items identified by the expert panel. And in the 3rd phase, we asked our expert panel if they want to modify their answers. Nothing significantly has changed, just a few moving between in the ranks of 2 constructs, but the results were solid. Here you can see opportunity constructs on the travel behavior level. For example, we had social and cultural factors play a more important role with an average of 4.55. And within economic dimension, we had unjustified rights decline with an average of 4.61. And for environmental, we had spike in using green mobility with an average of 4.76. On the urban infrastructure level, within the social dimension, we had considering people needs over cars in planning urban infrastructure with an average of 4.72. And within the economic dimension, we have commercial interest for digitalization increases with an average of 4.77. And for environmental, we had rethinking of urban planning to protect the environment with an average of 4.61. On challenge on the travel behavior level, we had lack of trust among passengers with an average of 4.81. Within the economic dimension, we had riders spend less money on transportation with an average of 4.66. And within the environmental dimension, we had trivialized environmental issues with an average of 4.55. Again, About challenge on the urban infrastructure level, we had within social dimension, scarcity of urban infrastructures for imposing social distancing policy with an average of 4.72. Within the economic dimension, we had reduction in investment in mobility infrastructure with an average of 4.61. And within the environmental dimension, we had environment issues in urban areas rise with an average of 4.55 as our final constructs. You can see here final constructs or key opportunities and challenges on travel behavior and urban infrastructure level. You can see that we had 12 final constructs, 6 opportunities, and 6 challenges, and their level of applicability, both at the travel behavior level and urban infrastructure level. So I'm going to go ahead and have a discussion over social attitudes and cultural factors at first, because I believe that this pandemic by its nature imparts a dramatic force perspective on social attitudes and cultural factors, because it has shown differences between societies and also their individual economic, social, and cultural differences. And because of that, coping with impacts of COVID-19 highly depends on human factors. Also, social attitudes could change the adoptions of new technologies, and socio-demographic trends will affect travel demand more during this time. So any responses to the consequences of the pandemic on the sharing economy may consider the solidarity situation within communities, both mechanical solidarity and organic solidarity. Mechanical solidarity is about the social integration of people within a society who have common beliefs and values. On the other hand, organic solidarity arises from the need of individuals to one another's services. That's actually mutual interdependencies. People come to depend on one another to meet their needs. And a functioning society requires different people to perform different functions. About social trust that we have talked about this in literature review, we could see that low social trust is positively associated with reduced citizen mobility. But the important thing to remember is that trust concerns are not going to be eliminated as easily as they have been developed. We should know that trust in the sharing economy subdivides in 4 categories: trust to the seller, trust to the buyer, trust to the platform, and trust within the community. But what is trust? Trust is a peculiar belief predicated not on evidence, but on the lack of contrary evidence. And that's a feature that makes it more vulnerable to deliberate destruction. And for that, to foster public trust in shared mobility again, we should focus on the lack of contrary evidences and ultimately rebuilding trust beliefs. For that, we could take these steps like staggering working hours, wearing a protective mask, disinfection, limiting contact, providing occupancy level monitoring, help to get essential workers to workplace, and also supporting drivers and frontline workers. And also to ensure the implication of social distancing in crowded public transit right now, we could use urban anomaly detection, crowd manipulation, and also have a good system of monitoring social distancing. For the economic dimension, it seems that this disruptive pandemic has made these constructs, this pre-existing challenge for shared mobility more stronger. Constrained budgets, regulatory requirements, record unemployment, and rising costs of running services. And because of reduction in investment in urban infrastructure, the transportation industry needs financial support and physical facilities more than ever. But the good news is that the COVID-19 outbreak and its impacts have increased commercial interest in digitalization and developing new technologies. We could see that all around the world. But the bad news is about the environment. The pandemic has derailed many of plans for tackling climate change. And this pandemic has disrupted many actions for promoting the increase in the average occupancy of vehicles with carpooling, or promoting a shift from private cars to public transport and clean car sharing. Here you can see the change in mobility derived from Apple reports. Here we can see change in Rome, New York City, and also London. And you could see that public transit has been hit more severely. But hopefully, with the current pace of vaccination, it's going to rise again. But every time there's an outbreak, and following that, there's a lockdown, you could see that public transit hits again. So by calling for a so-called green recovery plan in transportation, we can take steps towards low carbon production and a more sustainable and environmentally benign mobility. A sustainable transportation, in comparison to business as usual, emphasizes quality, interconnections, the plurality, stability, and also integrated urban planning. But an integrated urban planning needs to be people-centered too. And for that, we should trust the locals, because responses without community leadership tend to make matters worse. This pandemic has opened our eyes to novel ways of living and working, in which we can assure economic growth, not in a way that harms the nature, but in a way that brings sustainability. It is a very foolish version to want to have both, but it seems not unlikely. Thank you for your attention.
All right. Oh, what happened in the chat box? I could see nothing. I don't think unfortunately, we don't have Amirsalar here. He just sent me an email. He's in the northern part of Iran that he doesn't have a good internet connection. So he apologized a lot, and he's wanting everybody who has questions to send him an email or use that Twitter account that he had in his presentation. So yeah, unfortunately.
I'll send in my question. Thank you so much.
No worries. All right, I guess we can go ahead with the next presentation. It's good for the next presentation. We have like 8 minutes more. All right, so I'm just gonna introduce. Okay, and next presentation is required simulated population ratios for valid assessment of shared autonomous vehicle with agent-based models, which is going to be presented by Yeow Kamijo, which is a PhD candidate at the University of Tokyo Graduate School of Engineering. His research topic is impact analysis and exploration of operational methods for new mobility using agent-based simulation. All right, so I'm gonna stop sharing my screen. We have Yeow here. Oh, no, yes. Yeow, can you hear me? Yeah.
Yes.
Hello.
Let's share my screen. Yeah. Can you see my slide?
Yes.
Yes.
Okay. Thank you for your kind introduction. Good afternoon, everyone. I'm Yeow Kamijo. I have sent a URL where you can download the PDF of the presentation slides to the chat. So please have a look if you like. My presentation title is Required Population, Simulated Population Ratios for Valid Assessment of Shared Autonomous Vehicles with Agent-Based Models. The structure of this presentation is like this. First, I will talk about background of my research. The transportation field is in a period of major change due to new technologies and services, such as mobility sharing, ride-hailing, mobility as a service, and autonomous vehicles. As such, there is a great deal of uncertainty about what forms of service will be accepted and what impact will they have on transportation cities. In particular, services that operate AVs as mobility-on-demand shared fleets, so-called shared AVs, are attracting attention. Since the behavior of both individuals and vehicles are important factor in the analysis, it is considered appropriate to apply agent-based simulation that can capture the interaction between individual and vehicles. Previous studies include large city in target area, and it is computationally expensive to handle all trips by simulation. Therefore, it is common to simulate only a fraction of the population, what we call here simulated population ratio. However, to the best of my knowledge, there are very few discussions about the validity of the simulated population ratio. To briefly explain how important the simulated population ratio is, for example, as shown in these figures, 10 SAVs are in operation at 100% ratio and 1 at 10% ratio in certain area. At this time, considering the dispatching time, you can see that 10% ratio causes a bias that increases the dispatching time. This means that more than 10% of vehicles will be required to maintain 100% ratio, dispatching time, and level of service. At lower ratio, other possible effects are more vehicle kilometer traveled, so-called VKT, and lower profitability of the SAV operator. Maybe the magnitude of the bias may differ for each evaluation index, and the influence of SAV operation strategy, such as using dynamic ride sharing, so-called DRS or not, is large. This is easy to imagine, given that low request volume may cause poor efficiency of DRS. This is a bias due to the reduced chances of matching carpools in good conditions. From the study background so far, our research objective is to analyze not only what ratio should be used to obtain results comparable to the 100% case, but also the bias that stem from using low ratio for each evaluation index. For that purpose, we prepare a plausible and easy to understand SAV simulation environment and test different simulated population ratio ranging 2% to 100%. From the next slide, I will explain specific research methods. First, let's talk about the simulation framework. For the simulation, MATSIM, an agent-based transportation simulation framework, was used. A feature of MATSIM is the co-evolutionary algorithm that plausibly reproduces the demand for non-existent mode, such as SAV, by repeatedly executing mobility simulation and schedule planning. The MATSIM simulation was repeated until the average waiting time of SAV was 3 minutes within a plus or minus 1% error range. At that time, as a method of adjusting the simulation, taking advantage of the tendency that average waiting time decreases monotonically as SAV fleet size increases, it converts by performing a binary search of fleet size. Why do that? When comparing the results, there is a problem that the analysis results differs greatly depending on how the fleet size is changed when the simulated population ratio is changed. In our research, as a possible relational decision method, the fleet size was estimated using a binary search algorithm. So the reason for converging the fit size is to compare the simulation results of each population fraction with the same uniform average waiting time, in other words, with the same level of service criteria. This allows us to compare free sites that achieve the same level of service. As a specific example, this graph is an excerpt of the results of this study, with the horizontal axis representing the simulated population ratio and the vertical axis representing the fleet size. The blue dots indicate the converged fleet size, and the black cross marks indicate the trajectory of the binary search. The binary search is performed in this way, and the number of the converged vehicles is compared. Regarding the scenario settings, we used a level of simulated population ratio. Simulation using 2%, 5, 10, 20, 40, 60, 80, and 100% of the total synthetic travel demand in the region are simulated for without DLS and with DLS scenarios. A total of 16 scenarios were generated. The definition of without DLS and with DLS in our research is shown in this table. The difference is passenger capacity, carpooling or not, and fare. Next, the three key contents of this simulation are explained. First, synthetic population to generate total travel demand. The target area was 120 kilometers northwest of the center of Tokyo in Japan. It's a local small city in Japan with a declining population and is a region highly dependent on private cars. The mode share of car is 81.7%. The bounding box of the simulation has an area of about 900 square kilometers. Its population is about 80,000. The population is extremely concentrated in the central part of the target area. The target area is surrounded by mountains and is relatively isolated from the surrounding city, which is also suitable for simulations that handle only trips within the target area. These 500 meter by 500 meter mesh grid was used for synthetic population. According to this flow, we synthesized 65,000 travelers aged 5 or over, which is 100% of the simulated population ratio. For more information on the synthetic population, please see appendix. Next, discrete choice model related to demand estimation of each mode will be explained. We conducted a stated preference survey in the form of web questionnaire to make the demand for SAV in the simulation plausible. The survey period was April 14 to 19, 2020. This SP survey targeted residents of the 3 northern Kanto prefecture. The survey target area covered the target area of the simulation. 160 respondents were shown choice scenario of SAV without DLS. 161 respondents were shown choice scenario of SAV with DLS. 4 SP questions were presented to respondents with a choice set of SAV, walk, and bike only if they own a bike. The cost of SAVs presented in the SP survey was calculated based on Abe's previous study, which calculated the profitability and cost of SAV services in Japan. In doing so, we set 3 scenarios of changes in cost due to autonomous vehicles, as shown in Table 3. Table 4 shows the attributes and level of each mode presented in the SP choice question, including the SAV cost calculated based on Table 3. Based on the collected SP data, we conducted a mixed logic model. The estimation result of the model are shown in this table. The magnitude of value of time are also within the appropriate range. So the utility of the schedule in the simulation is scored based on this model. Next, I will explain about SAV service settings. First, the SAV service setting in the simulation were matched as much as possible to the SAVs in the SP survey. passenger capacity for SUV with DOS was set to 1, while the passenger capacity for SUV with DOS was set to 4 persons. The SUV fare was set to low cost scenario in previous table 4. Next, big assumption in the simulation is that only SUVs travel in the road space, and the mode choice set of agents is SUV, walk, and bike. Regarding SUV's dispatching algorithm, the algorithm processes requests by minimizing the sum of increases in total weight and travel time resulting from detour to pick up and drop off all passengers. Total weight and total travel time of the SUV itself. Requests are processed statically, meaning that the existing requests are not re-optimized. About initial distribution of vehicles, vehicles were placed for each 500-meter mesh unit with reference to its population. Next, let's move on to the analysis of the simulation results. I will compare 16 scenarios for each indicator. In all figures shown below, the horizontal axis is the simulated population ratio, in other words, the number of travelers, and the vertical axis is the variation index for comparison. First, this figure shows the changes in the average waiting time as the convergence standard. For each scenario, since the search was performed by changing the fleet size until the average waiting time of SUV was 3 minutes within a plus or minus 1% error range, so the average waiting time is within that range. This figure shows the changes in the mode share. The fluctuation due to the simulated population ratio is small because it is closely related to wait time. Next figure shows the changes in fleet size of SUV. Compare with the dotted line with equation 100%. In with DRS case, when the ratio is low, the fleet size deviates from the tendency and increases. This figure is a little confusing, so please look at the next figure. This figure shows the travelers per SUV. In without DRS case, the error range can be kept within 10%, even at a ratio of 10%. While for with DRS case, the required ratio was up to 40%. This figure shows changes in VKT per travelers and changes in empty VKT ratio. For the without DRS case, left figure shows the simulated population ratio has little effect on the total VKT. On the other hand, regarding empty VKT ratio, when the simulated population ratio decreases, empty VKT ratio increased due to the decreasing in the number of surrounding vehicles that were convenient for dispatching. For with DRS case, VKT per traveler increases due to worsening ride-sharing conditions when the simulated population ratio is low, and the error range of 10% could only be maintained for ratio of 60% and larger. The empty VKT ratio increased significantly, and the error range of 10% could only be maintained for ratio of 80% and larger. This is thought to be due to both the low vehicle density and poor ride-sharing allocation conditions. This figure shows the changes in the operation profit margin of the SUV operator, calculated from the simulation results using the number of operated SUVs, total VKT, number of SUV trips, and total fare. While for without DRS case, a simulated population ratio of 10% is enough to maintain the error in a 10% range. For the with DRS case, the required ratio is at least 80%. In with DRS scenarios, profitability depends on ride sharing efficiency, reduction of SUV fleet size, and reduction of VKT. Therefore, predicting profit margin cannot be adequately calculated with low simulated population ratios, especially in with DRS scenarios. Let's move on to the evaluation indicators specific to with DOS scenarios. This figure shows the average passenger occupancy and passenger occupancy ratio. The average passenger occupancy is the average value when there are one or more passengers. Regarding average number of passengers, it was found that the error was not within the 10% range when the simulated population ratio was 40% or less. This figure shows the changes in the average literal ratio. The definition of literal ratio is the ratio of the distance travel used with DOS and the distance of the route with the shortest travel time in the without DOS case. The frequency of ride sharing itself was reduced, resulting in lower literal ratio for scenarios using low simulated population ratios. Finally, I will summarize the results of each indicator. A guideline of less than 10% error against the 100% population ratio case has been used in previous discussions. However, what percentage of error is acceptable depends on the purpose of analysis and the evaluation index used. So, in addition to the minimum simulated population ratio required to keep the error under the 10%, this table summarizes the minimum ratio for less than 5% and less than 20% cases as well. In without DOS case, regarding all indicators except for MPT-VKT, a simulated population ratio of about 20% is required to keep the error within 5%. And a simulated population ratio of 10% to keep the error within 10%. On the other hand, in the with DOS case, simulated population ratio of 80%, 60%, and 40% are required to keep the error within 5%, 10%, and 20% respectively. For all indicators excluding MPT-VKT ratio and operating profit margin. Next, I will summarize the research results. It became clear that when performing a simulation using SAV with DOS, it is necessary to handle travel demand on a scale close to reality. We expect these results will serve as a guideline for selecting simulated population ratios according to the required accuracy level and the evaluation index to be used. Minimum simulated population ratio required to keep error under 5%, 10%, and 20% were also shown for each evaluation index. The magnitude of the bias from the simulated population ratio differs depending on the evaluation index. Indicators such as MPT-VKT ratio and operating profit margin are considerably biased. On the other hand, the limitation of this study concerns the generalizability of the results. The target area in the study is a local small city with low population density, and it is possible that such areas are more susceptible to simulated population ratio bias. Further studies should be conducted to evaluate the performance of similar simulation studies given different built environment conditions. For example, different population density, land use mix levels, transport infrastructure. Another limitation inherent to this type of study is that results are conditional on the setting and assumptions used in this study. For example, if the SAV's dispatching algorithm is changed or rebalancing strategy is introduced, the simulation population ratio bias might change. A sensitive analysis are required to evaluate the robustness of these results given changes in simulated setting assumptions. Although there are such limitations, I think that the bias trend and direction itself are robust results and useful in interpreting simulation results. That's all for my presentation. Thank you for listening.
Thank you very much, Yeow. There are a few comments from Cara. Would you like to go ahead?
Sure. First, thank you. This is so great to see. You know, whenever we do dynamic ride sharing, that's part of the reason we shifted from MatSim to Polaris, which is proprietary. So I'm afraid people can't use it very easily. But is we wanted to get those numbers up so we could take a look at we wanted to be able to scale up the population population and demand to be able to see how higher probabilities of ride sharing, because you have more people that might align in space and time, would improve the vehicle occupancies. But I noticed that you had, empty VKT falling towards 0 or 4%. But if you compare it to people driving themselves, I think you probably go negative on VKT, even without forcing people to share. Is that correct?
Thank you for your question. You mean the empty VKT ratio effect negative on total VKT than normal car?
Right. So I think you have less congestion when you get rid of cars, because even if people aren't sharing very often, they probably walk and bike more, and because they don't have to bring the car home, they may take the car with them, they may take an SAV to work, but then they can always take a different mode home. Have you tried that simulation?
Thank you for your question. Because of my poor English listening ability, could you please repeat slowly again or write in the chat? Sorry.
Right. My questions are in the chat box, so feel free to answer them there during the next speaker or whenever you like. But I think an easy question is, what is the mode split for car in the Tokyo region?
What type of car split in the Tokyo in the future?
No, presently. What is car mode split right now in Tokyo?
Now, okay.
Or pre-COVID.
Yeah. In Tokyo, the public transportation, like train or bus or taxi, is spread in the center of Tokyo.
Okay, thank you.
And there is also, sorry, go ahead.
Just a support, Kamijo, I think this refers to the Tokyo metropolitan area, not in your target area. Why is the car model scale? In the Tokyo metropolitan area, or in the Tokyo 23 wards?
So Giancarlo, you are feeding back your microphone, so none of us can actually understand you. You may want to type your question.
Yeah, before that, there was another question from Niraj that he asked which software you used for simulation.
I used the MATSIM, the transportation simulator framework. That's enough answer. I use MATSIM software.
Thanks for that, Yeow. I just was typing a comment here. Could you share the link with us so that I can read more about it? I'm quite curious to know more about this software. So if you could share the link with us, that will be really good. And a very good presentation.
MATSIM or presentation slides?
No, for MATSIM, the simulation tool which you used. So can I read something about that simulation tool? If you could provide any link for that.
The home page link is now I write in the chat the link of the
software. Thank you. Thank you.
If you would, we still have 2 minutes for this session. If you would like to can you see the chat box? I don't think there's any more question in the chat box apart from Kara's question. So yeah, if there is any other question.
Anyone have any questions for me? You know, I do a lot of SAV work, and I know he's having a hard time because Japanese is so different from the language of this conference. And so, you know, we're so grateful to all of you using a second language in this conference for us. Thank you so much. Arigato.
Thank you so much too. That's great. What is the mission of this people to
All right, I guess, oh no, actually we have 10 more minutes, sorry.
I will answer the question about what is the ratio of SAV to people to trips per day. It is the average travel length of trips in target area we synthesized is in this table. So this include walk and bike, so it's different from SAV only, but maybe in agents travel 4 kilometers by trips. Does that answer the question?
Yes, thank you. If anyone wants to talk about Polaris versus Matsim, please feel free to unmute yourself. Unless you're going to feedback your microphone with your speaker, Giancarlos.
Okay, can you hear me better now?
Your microphone is still the same.
I might be able to interpret, but it's tricky.
It sounds like aliens.
It's supposed to be the same.
Oh yeah.
It's fine. Go ahead.
Okay. No, I was saying like there's also Yamamoto-sensei's question about the population density. He said, "How did you treat population density?" Let me start again.
Yeah, I'm not sure what the question, how he could answer that. How did he treat population density? You mean if he's only sampling 10% of the trips or something, then I'm afraid he's going to have 10% of the density of trip making, and he's not going to be able to make good use of the ride sharing.
I'm not sure about the content of the question either now that you mentioned it. So you say like in parallel to the Yamamoto-sensei, can you specify?
Yes, sorry. I asked about the Kamijo's presentation, not the Kara's presentation. I don't know.
Yeah, I think, yeah, exactly right. So how did he treat population density, right?
Yeah. So if you use 50% simulated population, the population density becomes lower, right? if you use the same area. So I said that I might overlook your the presentation by Kamijo, but
I think the area is the same, right? So that's the reason that we see the bias in the indices we're using is because the area stays the same. So there is then you have like network effects that are not accounted for in the, when you use the population.
So if the density becomes lower, the chance for the sharing, dynamic ride sharing becomes also lower, right?
Yes. He has the rule to scale down the supply. Yes.
Okay.
Do you want to add some more information about that, Kamijo? How did you change the transportation supply based on sample population ratio?
I adjusted free size by each volume of travelers, like in this graph. So the supply side, the percentage the tendency is in low ratio. The supply side vehicle is large than high ratio.
Was this done with binary search? Was this a thing you did with binary search?
I used the binary search for free size. The lowest value and highest value is the initial volume of SAV vehicles.
All right. I hope you get your answer. So I think we kind of need to stop this session for now because Messi is here to start the next session. So thank you very much, Yeow, for the great presentation.
Yeow, I still have a couple easy questions in the chat box, and once you minimize your screen, you'll be able to see that more easily. But thank you very much.
Thank you for your questions.
Yeah, I think if you stop sharing your screen, then you can see the chat box much easier.
This shows trips number and the okay.
We're going to go ahead and take over this. You can answer in the chat box. So go ahead and exit, stop sharing, or whoever is the host can start sharing their slides.
Yeah, if you can stop sharing your screen now.
Okay.
Thank you.
Any of the hosts can take over at
yes.
this point.
So yeah, after that, you can just answer the questions in the chat box later.
Okay, thank you.
So I think I'm just going to hand it over to Messi. Messi, can you hear me?
Well, until Messi gets on, I'm going to let you guys see my dog.
Yeah, we can have like 2 minutes tea break.
Here's the dog break.
Oh, no.
It's 11 o'clock at night here in Texas, so the dog is asleep.
Oh my God, I'm so jealous actually.
He's amazing. He's amazing. Yeah, he's had like 4 walks today.
Oh, I can tell he's so tired. I wish I had a dog in the house as well. We are in quarantine at the moment, and I'm just
Yeah, dogs are very popular during COVID.
exactly, yeah.
Say hi. Say hi. Okay, I've lost my screen here, so I'm gonna have to alt tab over. Okay. Ooh, look, we've got this screen.
I can see your screen, Massey, so I think I can hear your voice as well.
Yeah, sure. Give me a sec, please.
That's right.
While she's taking that second, I don't think Ellie mentioned this when Becky was presenting to kick off today's Eastern sessions, but this is the Olympics of transportation research, guys. So thank you to our friends in Tokyo for putting on the sporting Olympics. This is the transportation research Olympics that you guys are participating in. You're all athletes. You're all exceptional. You know, this was peer reviewed, and of course it is bringing people together across lots of nations and hundreds of universities, and of course across languages, all competing in English here. Sorry about that. That's a sort of a biased situation for those of us whose first language is English. But you guys are going to take the gold medals. Those of you who are having to step out of your native language, we really appreciate it.
Yeah, I think that's a good thing that we are forced to learn another language. So.
Yeah, well, I can deliver in Spanish, but I cannot deliver my slides in any other language besides English and Spanish.
I can do Spanish too.
And Italian, Giancarlos?
No, my native language is Spanish. Only the name sounds Italian, but has the S in the end. It's not really Italian anyway.
Lo siento.
Okay. Hello, everyone. Let me turn on my cam as well. I'm Dr. Maisie Raber from University of Queensland. And today we have 4 presentations. Can you hear me?
Yes.
Yes, great. So each presenter has 20 minutes, and at the end of each presentation, we have 10 minutes for questions. We will start with the first presentation if there isn't any question beforehand. And the first presentation, Houmaan will present it. Actually, I have the recorded version of that. So I will play that. And at the end of presentation, we have 10 minutes to ask your questions from Houmaan or Ali, either of them who are here. The title of presentation is Applying the Integrated Model to Understanding Online Buyers' Intention to Adopt Delivery Drones in Iran. I also would like to give you a short bio of Houmaan.
Houmaan can also give his own bio if you can't find it.
Actually, I shared my screen, and for a second, it ruined everything on my computer, but I will get there. Give me 1 sec. Well, I think I didn't receive any bio from Houmaan. So that's the reason that I cannot find it. So I will play his presentation.
Massey, the sound is really poor for all of us. So I don't know if you can hear it well in your office, but it's very poor for all of us. Do you think he recorded it poorly? Massey, can you hear me?
Yes, I can hear you. Yeah.
Can you hear him? I cannot hear him, so I don't think the others can hear him either.
No, it's not really poor.
I don't know why Houmaan could not be on today, but maybe his co-author Ali is available.
I will try to replay it. Please let me know if you can hear it.
No, I think still there's some issues.
Since Massey can't play it properly, but she seems to think it sounds good, would you mind go ahead and grabbing that, Ellie, and playing that for us?
Yeah, I just need to go find this file actually. If you give me a sec.
I will send it to you.
Does anybody want to see the dog again? Anybody want to share their animal?
What is the number of the paper, Massey, if I can?
The number of
Is it 17 now?
It's 19.
No, 19,
Yeah.
19. Oh yeah, drone delivery. Yeah, I can find. I can see it now.
Any guesses by attendees why Massey's speaker won't play this properly?
Hopefully mine does.
Yeah, maybe he recorded it improperly.
Yeah. Alrighty, let's see if this is gonna work.
Hello, everyone. Our paper is about the adoption or acceptance of delivery drone as an alternative method for last mile delivery in Iran. We investigated the factors affecting the intention of individuals to use delivery drones in Iran. So we will talk about the features and characteristics of delivery drones in introduction section. Then we will discuss the important studies about the acceptance of this system in all over the world. After that, we will explain the hypothesis and the theoretical framework of the present study. Then we will talk about the methodology, the design of questionnaire, the data collection. And after that, we will talk about the modeling and results, for example, structural equation modeling or SEM. And eventually we will explain the conclusion of the present study and the practical contribution. Delivery drones are unmanned helicopters in different sizes for the last mile delivery. These drones have many advantages compared to traditional methods of last mile delivery, such as the fast last mile delivery, lower energy consumption and air pollution, lower costs, and reduced traffic. In Iran, delivery drones are in the design and experiment stage, and they have not been executed and adopted yet. So it seems important to identify the factors affecting the intention of individuals to use delivery drones in Iran. So we combine UT version 2, DOI or diffusion of innovation theory, CCT or consumer co-production theory, and some psychological characteristics and also security concern to investigate the factors affecting the intention of individual to use delivery drones. So in the literature review, you have some important studies about the acceptance of delivery drones. For example, Yeow et al. 2018 investigated the impact of perceived risks, innovativeness, environmental concern, and the variables of diffusion of innovation theory on attitude and intention to use delivery drones. And the main findings was that relative advantage, compatibility, innovativeness, and perceived risks affect drone delivery adoption. Huang et al. 2019 investigated the impact of innovativeness on attitude and intention. They used the structural equation modeling with 324 samples. The main findings, positive effect of innovativeness on attitude and positive effect of attitude on intention to use delivery drones. Already in 2019, investigated the public acceptance of drones with a KAP model, or knowledge, attitude, and practice model. The main findings is that the public acceptance of drones for different applicants and related to slight concern about the probable risks of using drones. And Huang et al. 2020 investigated consumer innovativeness in the context of drone food delivery, or consumer innovativeness, or CI. They use structural equation modeling, and main findings is that positive effect of novelty seeking, hedonic experience, and social distinctiveness on attitude, and actually positive effect of attitude on intention to use delivery drone. Huang et al. 2020 used TPB, or theory of planned behavior, to understand the eco-friendly role of drone food delivery. The main findings: positive effect of attitude, subjective norm, and PDC, or perceived behavior control on intention. Also, they investigated the mothering role of awareness of consequences. Kim and Huang 2020 merging the NAM and TPB, or norm activation model, and theory of planned behavior. The main findings: the positive effect of personal norm, attitude, subjective norm, and PBC, or perceived behavior control on intention to use drone food delivery. They also investigated the moderating the role of product knowledge. And eventually, Jafari et al. 2021 used EOI, or diffusion of innovation theory, TAM technology acceptance model, and PMT, or protection motivation theory, to investigate the factors affecting attitude and intention to use delivery drones. The main findings: significant effect of relative advantage and perceived risks on attitude, and positive effect of attitude on intention. So we can see the proposed model of this study. We have a UT version 2 here with 4 variables, some psychological characteristic factors like compatibility, innovativeness, environmental concern, and personal norm, CCT, or consumer co-production theory, with 1 variable need for human interaction, and eventually security concern factor with 1 variable, perceived risk. So we have 13 hypotheses for this study. For example, compatibility has positive and significant effect on performance, expectancy, and effort expectancy. Innovativeness has positive and significant effect on these variables. Environmental concern has positive and significant effect on personal norm, and then personal norm has this positive and significant effect on intention to use drone delivery. In UT and UT version 2, performance expectancy, effort expectancy, facilitating conditions, and hedonic motivation have positive and significant effects on intention to use delivery drones. But in CCT theory, or consumer co-production theory, hateful human interaction has a negative effect on intention. Also for perceived risk. For security concern factor or perceived risk, we have a significant and negative effect on intention. An online questionnaire was designed in the present study and distributed among the target population. Means Iranian users who had experienced the online purchase of goods at least one time. In the design of questionnaire, in the present study, we have three parts. The first part of the questionnaire is the information sheet, introduce the performance, characteristics, and application of this system with several images, GIFs, and a video. The second section of the questionnaire includes questions about the latent variables in the proposed model, as we saw in previous slide. They are in 7-point Likert scale, from strongly disagree to strongly agree. And eventually, in the third section of questionnaire, the socio-demographic characteristics of respondents, such as age, gender, educational level, and household income, were asked. In the data collection of the study, we used the Google Forms platform to develop and distribute the online questionnaire. The questionnaire of this study was distributed through social networks such as Twitter, Instagram, and Facebook, online messengers such as Telegram and WhatsApp, and email banks for 2 months from December 2020. After collecting 404 samples, some of the answers were removed from the analysis procedure to ensure the quality of data. 357 samples were identified as reliable data. So the reliable response rate in this study is 88.4%. So in this table, we have some latent variables or main variables of the proposed model, and their observed variables or their questions, and their mean and standard deviation. For example, we have a performance expectancy or PE, which its observed variable or its questions in the questionnaire, or report expectancy, facilitating conditions, learning motivation, and other variables in the proposed model. Structural equation modeling, or SEM, was employed to evaluate the hypothesis presented in this study. SEM, or structural equation modeling, has two different kinds of methods: covariance-based approach and variance-based approach. Since the proposed model of this study has a complex structure and the research subject has not been completely developed yet. The PLS-SEM or partial least square was employed as a variance-based approach in this study. And the modeling procedure was completed using Smart PLS3 software. The measurement model expresses the relationships between the latent variables and their observed indicators. For example, in this study, we have some of the constructs or latent variables of the proposed model of this study, their items or their observed variables, their questions, the factor loadings, convex alpha, composite reliability, and ABE or average variance extracted. As we can see, all of the factor loadings are above 0.6. All of the convex alpha are above 0.6. CR or composite reliability are above 0.7, and ABE values are all above 0.5. So this table shows the other constructs or latent variables of the proposed model. As we can see, and according to the values of factor loadings, convex alpha, CR, and ABE, we can conclude that the convergence probability was achieved in this study. According to Fornell and Larcher, 1981, the square roots of ABE values for each latent variable should be more than its correlation with other latent variables. As can be seen in this table, the square roots of ABE values along the main diagonal were more than the correlation values below the main diagonal. And moreover, the HTMT ratio, the values above the main diagonal, should be less than 0.9. So we can conclude that the discriminant probability was also achieved for the current study. The structural model evaluates the relationships between the latent variables with each other. As can be seen in this table, all of the hypotheses were supported except of H1 and H7. So there was found not any significant effect of performance expectancy on intention fused delivery drones, and also innovativeness on performance expectancy. So for a conclusion or practical contribution, it is suggested to further promote the compatibility of delivery drones with the environment in advertising campaigns, educational seminars, and online advertisements. Comparison between traditional methods and delivery drones in terms of level of energy consumptions and environmental pollution can attract users to use this system. Also, green advertising through mobile applications and social networks can raise the users' awareness of the environmental damage caused by the traditional methods like the motorcycle, van, and cars. Also, the activities of this field can create a cyber environment through social networks or media, and to make users familiar with the whole safety and security dimensions and features and characteristics of delivery drones. Another important point is about the need for human interaction. If possible, designers can design the appearance of drones in more user-friendly form or add some features to them so that the individuals do not necessarily feel the need for interaction with a human or delivery man. It is suggested to effectively emphasize the interaction with drones and their advantage in some conditions. For example, during the COVID-19 pandemic. And eventually, it is better to provide a target population having a high level of innovativeness with facilities and conditions to test and more introduce this system. Thank you for your attention.
Great.
All righty.
Yeah, go ahead, Elham, if you want to say.
Pardon?
Okay, great. Thank you very much, Houmaan and Ali. I hope that you passed your exam today very well. I checked the participants to ensure that if Ali or Houmaan just in case finish their exam on time to be here to answer the questions, but they are not available. So their email addresses will be shared with all the audiences. If you have any questions, please send your questions to those email addresses. The second presenter is Abu Bakr Khan. I'm sorry, Abu Bakr, you thought that your presentation is for tomorrow, but surprise, it's for today. So
right. Hello, everybody. Thank you. Thank you. I actually, yeah, that's why I was kind of confused because I had a confirmation email from NLAS that, yeah, it's going to be on 6th of August, my time, Japanese time, 1 p.m. But surprisingly, when I saw my schedule today, but I wasn't actually planning to come today, but from the beginning, but luckily, coincidentally, I came. So now I saw my schedule. So yes, nevertheless, I'm prepared to present. However, I just have one humble request that I'm using my university Wi-Fi right now, and it's not doing a better job actually, because I wanted to present from my home connecting LAN cable. Is it possible that I can share the slideshow and then I can sit for the live Q&A? Will that be all right?
I think so, but you sound great. So I think if I were you, I would try to present it live.
I'm not hearing properly, actually. That's what I'm, because I don't know how I sound, but I don't hear properly, like I don't hear you guys properly.
You sound fantastic. There's an echo, but it's not a problem.
Oh, okay.
So do you want to give it a go, share your screen, and then we will give you a feedback if it's working good or not. And then if it's not good, then myself or Ellie, we can share our screen for you.
How about this? Is that all right?
I can see it perfectly.
Yeah, it's all good.
All right, thank you so much.
Abu, sorry, because you thought that your presentation is for tomorrow, so you didn't send me any bio of yourself. Please give us a short bio of yourself and then start your presentation. Thank you.
All right. Thank you so much. Well, allow me to share my video if possible. Can you guys hear me? Clearly.
Yes.
Okay, see me, all right? Okay, thank you so much. Good afternoon, everybody. It's 1 past half here in Japan, Osaka. My name is Abubakar Khan. I'm a graduate PhD student at the Graduate School of Policy Sciences at Ritsumeikan University in Osaka. I'm researching about, my PhD research is about housing and transportation, low-cost housing and integrating with transportation services in Rawalpindi Islamabad, which is my hometown in Pakistan. I've been in Japan for 8 years. I did my bachelor's here, my master's here, and I'm continuing my PhD here. Perhaps I can say that this is my second home. I'm okay with Japanese language as well. I saw the previous presentation from Japan. I really enjoyed it. I felt confident and inspired that some of the Japanese students are also presenting here. Yes, this is my short bio. I hope I can interact with you guys as much as possible. Is my voice clear here? I'm really scared because I didn't want to use.
All good, Abu. All good. Go ahead.
Okay. All right. Thank you so much for giving me this opportunity. Actually, one surprising thing also I wanted to share is that first email that I got from the BTR is that I got rejected. I felt really, really sad that I got rejected. And then right after a few seconds, I got another email that my paper was re-reviewed, and then the decision was that I got accepted for the presentation. So I got a bit relieved that I got accepted for this presentation and trying to present my findings. This is actually my very, very first paper of my PhD. I'm currently writing my third paper, and now I just entered my final year looking for postdoc or any other opportunity. Yes, so as time is short, allow me to present my presentation. Again, just in case, I'd like to turn off my video during the presentation. All right. Low-income people worldwide living at an absurd location in city peripheries with no vehicle ownership or no access to urban facilities, traveling long distances on poor quality transportation services usually report low transportation satisfaction that significantly impacts their quality of life. Today, I'd like to talk about similar and pressing issue by presenting a case study of commuters of bus rapid transit service in Rawalpindi Islamabad, Pakistan. Whether people can easily access BRT or must take another public transport as feeder to reach the nearest BRT, and the dynamics of such commuters is something I'd like to discuss today. My name is Abubakar Khan, the graduate student of Policy Sciences at Ritsumeikan University, and the title of my conference presentation is Measuring Survey-Based Trip Satisfaction of Feeder Modes for Bus Rapid Transit Service in Rawalpindi Islamabad, Pakistan. Bus rapid transit is a cost-effective system with rail-like characteristics. A complete BRT network consists of integrated high-capacity feeder buses with the main BRT corridor. Integrated feeder buses provide better access to BRT from residential areas, substantially increasing modal split. However, some developing cities like Rawalpindi Islamabad, as my hometown, Bogota, Curitiba, Lahore, Dhaka, and many others initially created BRT corridor without any feeder network. In such cases, existing informal transportation operators irregularly functions as feeder to transport commuters to BRT. Thus, it becomes nearly impossible to achieve expected results from the BRT built in this state. Whether paratransit can be an integral part of BRT, even after the modification, is still under the debate when planning mass transit systems. Transportation planners prioritize a comprehensive BRT network integrated with regular feeder buses to increase ridership, as evident in Bogota's case. Before the launch of BRT system called Transmilenio, Bogota's public transportation was filled with conventional paratransit such as micro and mini buses. The first phase of Transmilenio included paratransit operators as part of formal transit service. However, those paratransit operators did not live up to the drawn conditions by stakeholders and then were forced out of the main corridor lines and were replaced with formal high-capacity feeder buses. Similarly, Transantiago included paratransit operators in the system as a social responsibility. However, after the implementation of extended phases, those operators could not accept the formal regulations of the BRT stakeholders, resulting in their relocation to the peripheral regions of the city and were replaced with high-capacity feeder buses. Several studies have actually attempted to set the parameters that reflect commuters' perception of BRT's service attributes to determine service quality and the loyalty to the transit system. These qualities are set to compare the perceived satisfaction with the service quality promised by transportation operators. Though most studies have established interior service parameters, such as cleanliness, safety, air conditioning, proper seating, female compartment, and many more to determine BRT service quality, the exterior parameters, such as the access capacity to passengers to reach BRT via various modes, waiting time at bus stops, travel time, travel speed, and passengers' overall trip satisfaction from home to BRT demand extensive exploration. One study on Dhaka BRT attempted to integrate BRT with rickshaw services. They concluded that the incorporation of rickshaws with BRT remained challenging due to the vehicular structure of rickshaws, the integrated BRT station designs needed for integrated operation, and the distrust of the paratransit among commuters in general. One research in Bangkok concluded that despite high dissatisfaction of paratransit service quality for direct trips, passengers showed a positive attitude towards paratransit as feeders for mass transit systems. Moreover, the research suggested that improving safety, convenience, and comfort could increase commuters' satisfaction. Therefore, it has become essential to examine factors influencing feeder mode choice for BRT that can be a lesson for transportation planners in other developing states. The findings can identify weak aspects of paratransit for possible improvement from a policy perspective. For this purpose, this study is driven by following research question. What factors amongst commuter dynamics, satisfaction level with service attributes, and trip from home influence feeder mode choice to reach BRT? Rawalpindi Islamabad Bus Rapid Transit, or RIBRT from now on, was chosen as a case study to evaluate commuters' perception on the modes they chose to access BRT. The first phase of RIBRT Red Line was launched in June 2015. The first station on this corridor starts from the city center in Rawalpindi region and extends to Pakistan Secretariat in Islamabad region. Table 1 here actually shows the other characteristics. This RIBRT line is the first corridor with no feeder network. It provides access to only 8% of the people within 10 minutes of walking distance. Additionally, in this city, informal paratransit service comprising of 12-seater pickup wagon and 20-seater highest minibus also run. The fare of these services is not fixed. The fare cost of non-AC mini wagons is around 15 Pakistani rupees within 4 kilometers of travel distance. However, this fare cost increases up to around 33 Pakistani rupees within 30 minutes of travel distance. Moreover, a newly launched private transportation called Kareem, which is an Uber-like service, also functions as RIBRT feeder. It can be ordered from home using a mobile application as both a private service for a single client or share a ride service as carpooling. Since it's a private service with better cars, the minimum fare starts from 250 Pakistani rupees and increases with the distance traveled. These are the pictures that were taken during the case study field research in Pakistan in 2018. Paratransit services actually cover 95% of the mixed land of Rawalpindi. These irregular services are being privately operated in the Pakistani cities. They're not formally connected to RIBRT, yet they operate not only as BRT services, but they also transport people to the other parts of the twin cities. Pickup wagon and highest minibus, they cover the significant portion of Rawalpindi than they cover in Islamabad. First, I collected the ridership data of the first week of January 17 from Punjab Mass Transit Authorities. It's a government organization, also PMA. During my field trip, After analyzing this ridership data, 3 stations, namely Station 1, Station 6, and Station 9, were chosen as case studies. Due to time and cost constraints, the stations only in Rawalpindi region were selected. Station 1 is the first station of this corridor located in the central city of Rawalpindi, primarily occupied by commercial areas such as retail shops, restaurants, shopping malls, and education facilities. Station 6 has somewhat similar dynamics as Station 1, whereas around Station 9, other than commercial areas, the residential area can be found within 500 meters, providing better proximity from home. Given the lack of national or provincial data on transportation surveys, I had to collect commuter data by visiting the BRT station. And to my delight, I was able to collect 240 valid samples. The questionnaire survey included 3 parts. The first consisted of commuter dynamics. The second part section included frequency purposes like travel behavior indicators. The third part highlights the satisfaction of the service attributes borrowed from the previous studies. Table below describes the service attributes used in the study. There are 7 attributes: availability, waiting time, travel speed, safety, ease in transfer, and overall satisfaction. Additionally, trip satisfaction when accessing BRT from residential area was also evaluated. The survey participants evaluated these attributes based on 5-point Likert scale, 1 being the very dissatisfied, ranging to 5 being very satisfied. This is the visual representation of the respondents' travel modes from the origin when accessing the nearest BRT station. The data was geocoded in ArcGIS. The dots here represent the geographical location of the residents. The colors represent the travel mode, green as walk or bicycle, purple as kiss and ride, meaning some family member is dropping the commuter at the station, pink as rickshaws, dark blue as paratransit, and light blue as cream. Green and yellow regions around the BRT route illustrate 1 kilometer and 3 kilometer buffers respectively. It was worth noticing that some respondents used green services to travel more than 3 kilometers. Also, with the increase in the distance from the origin to BRT stations, it was evident that the travel mode choices became limited to only paratransit and cream. Therefore, this study limits the comparative analysis of paratransit with cream to assess the service quality. According to the descriptive statistics of the commuter dynamics, around 94% of the total sample ranged from 18 to 35 years with an average age of 23. Additionally, around 67% were male, 63.3% were students, nearly 60% had no income, and around 53% did not own any vehicle. Perhaps it is safe to state that majority of the BRT users were unemployed low-income people. It is understandable because BRT stations are within walking distance to schools, colleges, universities, and other educational facilities. As far as the travel behavior is concerned, Table 4 summarizes the travel behavior respondents when accessing BRT from home. The descriptive indicated that nearly 50% of the sample used BRT every day, whereas among the non-daily BRT users, the percentage differs from seldom users, once-a-week users, and twice-a-week users. Around 35% used BRT for education purposes compared to 31.25% of work-related travels. Nearly 46% of the sample used paratransit services compared to only 23% who used Kareem service. 15.83% used green service like walk or bicycle, and the remaining sample used rickshaws and kiss and ride modes that constitute approximately 15%. As far as the travel time in minutes is concerned, the majority portion of the sample could access BRT within 30 minutes, which is around 70% compared to 2.08% of the users who traveled for more than 1 hour to reach BRT station. This figure on the right-hand side highlights the cross-tabulation of commuter dynamics with paratransit and Kareem. It illustrates that young people under the age of 35 with income less than 75,000 Pakistani rupees, both workers and students, those with no vehicle ownership, and those who are daily travelers used paratransit more as feeder to access BRT. Further, this analysis also shows that car and motorbike owners preferred Kareem to reach BRT. Probably it's understandable because private vehicle owners enjoy their privacy, especially female BRT commuters. And also since Kareem is a door-to-door service that can be called using a mobile application, it is accessible from any residential location. This figure shows the satisfaction level of daily commuters using paratransit when accessing the nearest BRT station. The findings reveal that the respondents showed high dissatisfaction with safety, that is 50.8%, waiting time 46.2%, and travel time 41.5%, whereas ease in transfer to BRT stations and the availability of these services were the least dissatisfied attributes. The reason could be because, for one, paratransit operators, they operate on multiple routes around Rawalpindi Islamabad region and usually connect with the BRT corridor at some point. This connection possibly aids in transferring passengers from paratransit to the station without having to cross the signals in between. Secondly, highest minibuses or pickup wagons, they run in a very high volume around Rawalpindi, so people can easily catch them at any time of the day. On the other hand, this figure demonstrates the daily BRT user satisfaction with service attributes of Kareem. Unlike paratransit, Kareem users did not show any dissatisfaction with the examined service attributes. However, it was worth noticing that respondents showed a neutral feeling with the 6 service attributes other than safety, indicating highest satisfaction with safety level, that is 73.7%. The reason could be the comfort with the privacy, direct trip, comfortable ride, and so on that daily travelers usually desire. Overall, the daily commuter, BRT commuters showed a significant difference in service satisfaction levels of both modes. This analysis suggests that the Kareem provides high quality service to its commuters as compared to paratransit services. This study also evaluated the overall trip satisfaction to assess the commuter satisfaction level when moving from their home to the nearest BRT station. Figure A shows the trip satisfaction among daily and non-daily users when using any of the 5 travel modes mentioned in this study. The results clearly showed that this satisfaction was much higher among daily BRT users as compared to non-daily commuters. On the contrary, the proportion of daily commuters who felt satisfied was relatively low compared to the satisfaction stated by non-daily commuters. It may be usually because the daily commuters who commute to work or education facilities, especially when they're using low quality paratransit services, may feel stressed and would feel less satisfied with their overall commute. Furthermore, figure B at the bottom shows the trip satisfaction among those daily BRT commuters who chose either paratransit or Kareem service. The findings indicate that, and not surprisingly, Kareem users' dissatisfaction was far less than paratransit users when making a trip from home to the nearest BRT station. However, Kareem users did not show excellent trip satisfaction. Instead, their perception of being neutral was very high. It was also worth noticing that proportion of satisfied paratransit users was higher than Kareem users. Again, being economical, readily available on streets may contribute to this satisfaction level. Additionally, higher trip dissatisfaction among paratransit users may be due to low satisfaction with the service attributes that were discussed previously. I conducted a binomial. Yes.
I was sorry. You have 3 minutes to go.
Sorry?
You have only 3 minutes to go.
Okay, all right, thank you. I'm showing my binomial regression analysis that I conducted using SPSS. And due to the time limitation, I'm only showing predictors that indicated satisfaction, significant statistical association with the dependent variable, that is paratransit or Kareem. Among the socioeconomic indicators, auto owners showed a significant association when choosing paratransit in all the 3 models. The negative association means that those who own cars or motorbikes are less likely to choose paratransit as their feeders. Again, this could be because vehicle owners usually drive for daily travels to various destinations. Among the travel behavior indicators, the positive association of daily BRT users indicate that they are more likely to use paratransit. So people exercising various types of occupations among daily BRT users are inclined to take paratransit to access BRT, and because daily commuters usually are the main active users compared to other passive travelers who don't take BRT every day. As far as the satisfaction with the service attributes is concerned, 4 out of 7 predictors showed significant association with the usage. Among these 4 attributes, ease in transfer was positively associated, and it remained the strongest predictor amongst the service attributes, even after including all the controlled variables. The satisfaction with travel speed indicates a weak association. The inclusion of the controlled variables further weakened the relationship to a point that it became non-significant. The overall service satisfaction also indicated a similar situation. Also, the satisfaction with safety is the weakest and negatively associated, meaning that commuters indicated the highest dissatisfaction with paratransit compared to the Korean services. Lastly, the trip satisfaction was significant in Model 2 when controlling for travel behavior, and it remained significant even after the inclusion of the controlled behavior. This may be because low satisfaction was reported among paratransit users. The paper attempted to explore the accessibility-related issues and their influence on choice of feeder modes to reach BRT. The findings revealed that amongst the commuter dynamics, vehicle ownership had the most robust influence on paratransit being less likely to use this feeder and to reach BRT. On contrary, those who travel daily, regardless of their income, were more likely to use paratransit. This could be because of the location of the BRT corridor. The service attribute satisfaction predictors showed consistent output, indicating that people are less likely to use paratransit who have significant safety and overall service quality concerns. From the policy perspective, to enable our BRT commuters to use paratransit, it is necessary to strictly monitor vehicle maintenance, passenger safety, and timetable of the arrival at the stops and departure from the stops. Additionally, government must provide financial aid to paratransit operators that would help the operators maintain and modify vehicle to be considered for the possible integration with BRT system. This study has its limitations. First, the collected sample is very small and only the stations in Rawalpindi were selected. So in future, stations from the Islamabad with more sample can actually generalize the satisfaction level even better. Though it's not discussed in the paper, examining the commuter's willingness to walk to the transit from longer distances and willingness to pay for traveling long distances would also shed some light on overall performances of these small-scale public transportation services. Thank you so much for your kind attention. I'd like to open the floor for comments, suggestions, so that I can improve the paper and my research. Thank you so much.
Thank you very much. Is there any question? Beside the chat that I can read those questions, but if anyone wants to ask his or her question here. Okay, then let's start with the chat room. So the first question, can Karim also be requested through traditional calls for the underbanked? How is the smartphone market penetration in Pakistan like?
Actually, so Karim users would be very limited and probably middle class to upper class users, again, because of the limitation, because of their smartphone usage. But upon visiting, I felt like a lot of people own smartphone and they not only use to call Karim services, but they also use it for like food panda services, Uber Eats, like in Japan, and there's a food panda to deliver food and stuff. So people are inclined to use these kind of applications. And now Karim service and Uber service, there's another Uber service. They're emerging taxi services. So I would say that traditional calls or just using mobile application, I wouldn't say calling, taxi company. There is no such thing as, because there is no taxi union in Pakistan yet. So calling Uber, just as the way you call Uber from cell phone application, you look at the location. If there is a nearest Kareem driver moving around your region of origin, then you can just click on them and they would locate your location and it would just come to you directly. If you select them as your Uber captain, your Kareem driver, the driver is called captain in Pakistan. So calling, I wouldn't say, yeah, I've never heard of people calling them. It's just an app selection. They don't see your cell phone number. You don't see their cell phone number. You just see other information of how long it's gonna take for them to reach you. That way you can choose preference. And also car, what kind of car you want to use. If you want to use a motorbike, if you want to use a small scale car, if you want to use a minivan, you can also choose these, but the fare charges differ. Yes, so I would say it's called. I hope that answers the question.
The next question is, sorry.
The green service seems really big. Are there electric rickshaws in this? No, green service is only walking and bicycle. Rickshaw is a different mode. I calculated rickshaw as a different mode. Green service when walking. So bicycle, usually people walk. If they want to cycle, the BRT corridor, this one does not have bicycle parking. It was one of my suggestions in my previous paper that to provide bicycle parking in this corridor, but people usually walk. And by my analysis, the survey analysis, people walk a lot. Probably they're trying to save paratransit fare charge. They don't want to pay double. They don't want to pay a paratransit fare and then pay BRT fare. So they tend to walk a kilometer or 2 kilometers when they want to access BRT station. Did you mention effect sizes? I don't understand what effect sizes is. What do you mean by effect sizes? It would be interesting to know which variables are meaningful for policy making in terms of.
Can you hear me?
Please go ahead.
So when you show the model results, you discuss basically the results in terms of statistical significance. But in the end, I think what policymakers are interested in is like how big is the effect that you just identified, right? So like, have you calculated the elasticities or marginal effects to evaluate what would be the effect of these explanatory variables on your dependent variable?
So, for example, if I show one of my models here, for example, in my socioeconomic indicators, the first value shows the coefficient B, explanation of B coefficient on standard variable. It is the impact factor on the usage of BRT. And in parentheses, they are standard errors. So I would say that if this 2.627 is the strongest impact on the dependent variable.
But this is a logistic model, right?
This is logistic analysis.
Yeah, so in this case, like this is the effect on the marginal utility, but not the effect on the choice probability. So I think you have to calculate, to be able to say that, what you're trying to say, you have to calculate elasticities or marginal effects. So it's a little bit different from ordinal least squared regression, where you can actually explain the
yeah, in least would, yeah, the interpretation would be slightly different if it's least squared.
It's just a recommendation that it might be better to have the discussion based on the elasticity.
Sorry, please slowly repeat again, please.
It might be good to have the discussion based on the elasticities and marginal effects rather than just statistical significance.
So a discussion based on elasticity, marginal effect. Is that what you said?
And or marginal effects, yes.
And or marginal effect. Thank you so much for this suggestion. Thank you. Next question would be following up question. So what are the options for the underbanked? Anything on how informal transportation is like there? Can you please unbanked or underbanked? Is that she meant here. Is that Nathaniel Don? Yes, both. Okay. So what are the options for anything on how informal transportation is like? So informal transportation, though people, the local transportation operators, the government operators, they provide fair details the way they should charge, and they provide only routes, calculated routes, that certain number of small scale vehicles should run on this route and on during this time of the day. So peak hours, the numbers would increase, and non-peak hours, the number of vehicles should decrease because it affects the overall ridership. However, informal transportation, since they are not regularly monitored and they're owned by private people, even I can own a private paratransit. I can just buy one vehicle, register itself as a local transportation service, and get it run on the roads. So it's not being monitored properly, and people usually use it as a very last choice because they don't have any other option. So it's a very low quality service. Sometimes if the ridership is low, unlike BRT or transit, mass transit services, even if the ridership is low, they actually complete their route from one point to another point. But in paratransit case, if the ridership is low, they would not complete the route, and they would stop at a certain point and sell their passengers to some other paratransit who's actually going to the same direction. And they would come back to the main stop and start all over again. So this is a very poor quality system in Pakistan when in terms of informal services. I hope that answers the question. The green service should be, I'm not sure green service should be named for this since it is usually associated with e-mobility. I did not want to use green service as though, but one of the study in China, probably in Beijing or somewhere, used green service as walk, or if you're not using a motorized vehicle, then if you're using a non-motorized vehicle to commute, then it's said to be a green service. So you're contributing in the economy, eco service or something. So one of the researchers previously used this terminology. So my previous professor recommended to me to use this terminology. So I used it. It says, so I just active mobility, travel, or simply walking or biking. Simply walking or biking, sure, yes, okay. Thank you.
Thank you. Is there any other question? Okay, I take it as no. So thank you, Abu. Thank you very much for your presentation.
All right, thank you. Thank you so much for the suggestions. Thank you. I'll definitely take a look at it.
Geoff, can you please share your presentation with us? So Geoff is the next presenter, and the presentation is on the mobility as a service, or MaaS, the importance of transportation psychology. Geoff is a PhD candidate in marketing at INSEAD. His research is generally focused on how consumers will react to emerging technologies and understanding how to boost their welfare in such situations. Whenever that you are ready, so please share your screen and start.
Sounds good. So let's see if this works. So play from the start.
Yeah, we can see your screen. Thank you very much.
Wonderful. So thanks everybody for being here for the presentation. Yes, so my name is Geoff. I'm a PhD candidate in marketing at INSEAD. I'm usually based on the Singapore campus, but I'm visiting family in the US right now. So I'm currently in a basement in Kenosha, which is pretty exciting. So today I'll be presenting mobility as a service, the importance of transportation psychology. And the reason that we have a lot of co-authors on this paper is it came from a pretty interesting context. So there's a conference called the Choice Symposium, And you and a bunch of like-minded researchers get together in small groups, and over the course of a few days, you talk about kind of a big idea, and usually that big idea turns into a paper. So this was the paper that came from our discussions around mobility as a service. And actually, we have a couple of the co-authors in the audience today. Hello, Leonard. Hello, Huang. So without further ado, I will get started. So first, it's important to define what mobility as a service is. So the way that I would put it is mobility as a service is this idea that transportation can be a service, or maybe even should be a service, rather than something that we own privately. So for instance, if I own my car, then that transportation is not a service. I'm the one using something that I own to get from point A to point B. Whereas if I'm taking a bus, that is a service. I'm being transported by somebody else. So mobility as a service very strictly means that, but it usually also means kind of an app and platform context. So when I'm talking about mobility as a service today, I'm really referring to these apps and platforms. And what these apps and platforms typically do is you'll say, I need to get from here to here. And these apps will help you devise routes that are more so service oriented. And they'll give you different combinations of transportation. So for instance, if any of you use Google Maps is very close to a mobility as a service app. And some people even argue that it is one. Because if you say, I need to get from here to here, it'll say, take this bus to this train and then walk a little bit. But what I think really sets mobility as a service platforms apart from kind of a typical GPS service is that they also offer the payment integrated into the platform. So let me give you a good example of that. So this is Whim. Some of you might have already heard of it. It's a mobility as a service app that's based in Finland. And on the left, you can see an example. Let's say I'm trying to get from the Sibelius Monument to Sarina Stone. And essentially, oh, sorry, I'm just going to check the comments really quick, make sure everything's going smooth. Cool, okay. Whoops. So let's say I'm trying to get from this point to this point on the left, then it will, like a lot of GPS apps, give me these transportation options. But what makes it cool is on the right, you'll see a screen where it says book trip 235. So that means it's all integrated. It's essentially giving me the route while allowing me to book the route. So it's kind of a one-stop shop, the same way that a car is a one-stop shop, but instead it's a service. So what we talked about during the conference is we think that this is really exciting. We think that it's really important, but we're just a little bit skeptical about consumer adoption. So like I said, this is something that we think is going to matter a lot in the future. So a lot of major companies have been investing a lot of money into this, including Mitsubishi, BP, and Toyota. But again, we think that there's a lot of what we're thinking of as psychological roadblocks to adopting mobility as a service as a lot of people's primary mode of transportation. So that's really what this paper is about, is we're going to be talking about the different psychological roadblocks that we think might get in the way of mobility as a service adoption. And then we're also going to talk about future research avenues and some solutions to these roadblocks. So the first section that we're dealing with is perceived control. So within perceived control, I'd like to talk about psychological power. So psychological power is a lot like actual power, except for it's perceived. And those two obviously usually go hand in hand, but not necessarily. So what's really cool about mobility as a service platforms is they do offer a form of psychological power if they're marketed right. So for instance, you have a lot of modes of transportation to choose from. That's really great. You have that power. It provides you relief from erratic traffic conditions. Again, you can overcome these traffic conditions. That feels pretty nice. But the other issue is mobility as a service does prevent you from having power in other situations. So for instance, I say I want to get from this point to this point, and while it gives me options, I am surrendering some decision-making power. For instance, if I'm driving, I can turn wherever I want to turn. It's my car. Whereas if I'm in a bus, I don't have that privilege. So that's kind of the first dimension that we're looking at is with psychological power. Mobility as a service apps would do really well to highlight where you have power and would do better to kind of steer away from highlighting the aspects where you don't necessarily have power. And this has a lot to do with framing, what we're suggesting. Another component of perceived control is responsibility. So naturally, people do want to feel like they have control, but responsibility can actually be more of a negative thing. And much like with power, mobility as a service platforms do give you some responsibility, but they also can relieve some of your responsibility. So again, we think that they should be highlighting which parts of the apps relieve you of responsibility. For instance, the highly centralized payment options, and they also can offer contingency plans. So when your bus is late, they're going to be helping you out, figure out how to get to where you're going, rather than you having the responsibility to figure that out on your own. But again, what we're suggesting in this paper is that these apps should really focus on framing the responsibility alleviation rather than the things that add responsibility to you. Another major component is trust. So this is a little bit nuanced because with these apps, people don't really have experiences with these apps right off the bat, right? They're new. And that means that people might not necessarily trust them. They might not necessarily have brand names that people immediately go, oh, that works. So what we're suggesting that these apps do in the paper is they signal the competence of their network. So for instance, let's say I am running a mobility as a service app and we use Uber as a component in our app. Should be highlighting that, because then people say, okay, it's Uber, they're in good company. And that'll essentially signal the competence of your brand. Another thing that we're suggesting that might seem a little bit counterintuitive is, let's say one of your component brands, like let's say you're working with a subway system that just does not work well, or people just don't have a good impression of it. We're suggesting that the apps actually do something to help that component, even though it's not their fault. It's kind of a situation where we think even though it's not your fault, it is your problem. Because if one of the dimensions of your app is seen as a low quality thing, that might actually impact the impression of your app, especially before people have started to adopt it en masse. So the next major banner in which we look at mass adoption is consumer identity. So the first subset of that is dealing with self-signaling. So self-signaling is essentially how we signal desirable attributes to ourselves. So it's essentially, what choices am I making and what are those saying to me about myself? Now, usually when we talk about self-signaling in transportation context, we would be thinking about things like, oh, you know, I have this nice car, therefore I'm successful. But in a mass context, it gets a little trickier, because what are you signaling to yourself by using mass? Well, you might be signaling that you like convenience. That's not an extremely desirable attribute. You might be signaling that you like to save money. Again, not something that people want to brag about to themselves about having as an attribute. One thing that we think that mass apps could do well to highlight is environmental signaling. So when I'm using mass, I feel good because I'm helping the environment. But again, that's a little bit tricky of a thing to do. So that's something we're suggesting for future research and developers look into, is how do you get people to feel like they're self-signaling that they're helping the environment when they're using mass? And very similar points for other signaling. So other signaling is just, how are the choices I'm making, or what are the choices I'm making signaling to those around me and telling them about myself? So a lot of you have probably heard of conspicuous consumption. Again, this is just kind of managing other people's impressions of ourselves through our consumption choices. And I talked earlier about environmental signaling. This is even harder for other signaling, because let's say that I'm taking a bus. People don't even know that I'm taking that bus because I'm using mass. They may just think I'm a guy taking the bus. So what we're proposing as, again, a challenge for these mass developers is find ways for people to signal that they're using mass and that they're doing it for good reasons. And we think that that can help the adoption of mass. Because if I say, oh, by using this transportation option, people are going to think I'm super green, that might help people find mass to be more attractive, because they can send those positive signals to others. Next, I'll move on to social factors. But first, I'll check the comments, or it's not showing up anyway. Okay. So first, in social factors, we have social constraints. So a major factor in a lot of mass options is there's going to be crowds. If I take a bus or a train, there's just going to be crowds. And a lot of research obviously suggests that being in crowds isn't super fun for a lot of people. But we think that this can also be a benefit to mass, that there are going to be crowds around. Namely, what we're proposing is that mass developers do well on segmentation. So essentially figuring out what type of person wants to be kind of away from everybody else, what type of person wants to be with everybody else. And then ideally, once these mass apps become quite popular, they can actually segment people within the transportation options. So let's say I hate being around people. Maybe it puts me on a train that it thinks is going to be a little bit more quiet. So that way I don't have to be around so many people. Or maybe I love people. Then it puts me on a bus where there's going to be a lot of people, maybe even people that are like me. We even fantasize a little bit about a situation maybe where a mass app could, say like, hey, there's this person that's kind of by you that you have similar tastes to, why not say hello? So we think that mass could actually really make this social aspect something they can control and use to their benefit through segmentation. So next, let's move on to social concerns. So this is really kind of about scale. A lot of people don't necessarily want to just jump on board with a new offering right away. They don't want to be early adopters. So it kind of poses this challenge for mass of, how do you capture the zeitgeist? How do you make yourself seem like the hot new thing to be doing before you actually are? And again, this is a challenge that we pose for future research, is looking into how do you position yourself as an important new thing if you don't necessarily have the adoption rates to back that up. And that's kind of a common theme of this paper, is we're posing these research challenges and we're posing these questions that are very relevant to mass, but we hope that they're also really relevant to other fields as well. We hope they have a broader interest. So for instance, if you can find an answer to how do you appear popular before you are popular, that's a broad appeal to behavioral researchers as well. And next, I will move on to perceived costs. So first, I'll talk about salience of cost. So some of you might be familiar with something called the pain of paying. And essentially what that means is you're experiencing some negative feelings when you're paying money. Now, that is really, really important to mass, because the way that it works right now is you can have a pay-per-use model. So every trip that I take, I'm going to be paying a certain amount, or it can be subscription-based. So I pay a certain subscription amount, and then I'm just using everything within that subscription. Now, what there isn't a ton of research on, and what we're suggesting would be a really cool future route, is looking into what type of person experiences more or less pain to pain, depending on whether it's small but frequent or large but infrequent. Because we think that once you can figure that out, these mass apps can segment consumers on, okay, this person, we should market the subscription-based models to them because they're going to find that more attractive and feel like mass is a better option, versus this other person, maybe they don't really care about small payments, so we'll use the pay-per-use payment plan for them because they're not even going to notice those. So we think that this is going to be something really important for future research to do, is figure out how mass should segment consumers on these dimensions, so that way everybody can be in their most attractive payment plan. And then this is a really, really important point in terms of mass adoption. So switching costs. When I introduced this paper, a lot of you probably already thought of this. What we think is probably the biggest challenge to mass is going to be just getting people to move from their current preferred transportation option to mass. Transportation is very habitual. It's something that, for a lot of people, they identify very strongly with. So to get people to change their option, even if on the balance they would prefer the alternative, which is mass, it's very challenging. One approach that we're suggesting is not to frame the switch as a loss of your old mode of transportation, rather focus on the gain of what mass has to offer. For instance, commuters do value reliability. Why not highlight that mass is going to give you more reliability in your travel and commutes? So that's what we're suggesting, is try, when you're marketing mass, not to focus so much on what they're giving up, but focus more on what they're getting, even if what they're giving up is negative. So let's say you say, with your car, you're spending all this money on gas, you don't have to worry about that anymore. You're still focusing on what they're going to be giving up. And we think, just based on prior literature, that it'd be more advantageous to focus on what they're going to be getting. But again, there is room for future research on this. And then this is another interesting dimension that we look into in the paper, is this differentiation between predicted utility, which is before an experience, how much do I think I'm going to get out of it? Experience utility, which is during the experience, what am I getting out of it? So let's say, I'm using a mass option and I'm in the middle of changing from a bus to a train. What am I feeling? Am I feeling good about that? And then remembered utility, which is essentially, in retrospect, was this a good experience? And this is also an area where there's a lot of room for future research, is what are the nuances of these three different types of utilities? because this is going to be very important for mass, is understanding how to optimize each of these three different types of utilities within a mass experience. So what you do to maximize somebody's experience during a mass transit, for instance, making sure that they're on like a really smooth bus and, there's maybe minimal transfers, that might not be the same solution to optimizing their predicted utility, which is also extremely important for adoption. So that's something that we think is going to be very important for future research, is to look into these three different types of utilities and how they're going to relate to mass and how they differ from each other, so that mass apps can optimize their experience for people to have the most utility throughout. So in summary, these are the 4 categories that we looked at. And I'm not going to go through this figure because it's rather large, but in our paper, you'll see this figure, which essentially goes over the 4 categories and some of the solutions that we offer in line with these categories. So I just want to reiterate, it does seem that the biggest hurdle to mass adoption is going to be moving away from the status quo. So how do you convince somebody that absolutely loves their car to switch over to mobility as a service, to say you're not going to own your car anymore, you're going to just essentially get to where you're going based on what the app says, and that can include Uber, that can include trains, but it's not going to include you owning a car anymore. Because again, even if that is more attractive objectively to that person, it's going to be very difficult to get them to switch. So I think if we have any recommendation on, the big thing to focus on when trying to cause mass adoption, it would be, how do you get people to move away from the status quo? And also, I mentioned that a lot of what we talked about today were areas where there's a lot of room for future research. We also just want to touch a little bit on areas where there's quite a bit of research that we think mass apps can readily draw from already. So for instance, safety, there's a lot of research on psychological perceptions of safety. So we think that mass apps should look into that research and essentially design their apps accordingly. For instance, a lot of people are very afraid of certain train stops. So, but then again, like, they're actually more safe than a lot of car situations. So how do you make people feel at ease about, being at certain train stops that they might otherwise feel comfortable about? Another really, really rich literature is that of choice architecture. So you saw in the WIM example that there were all these different options. The research on choice architecture can really well inform how do you order those options, what should those options contain, and essentially just generally how should they be presented. So there's a lot of really good advice in that literature on how a mass app should present its options. And lastly, we did talk a lot about how mass should be personalized. So when you're personalizing a mass app, we suggest that you look not only into stated preferences, so not just asking, what do you want to do? Do you want shorter durations, or do you want fewer transfers? It's also important to look into revealed preferences. So at the individual level, what changes are you making to their routes that are making people happy? We think those are both going to be very important data sources to draw from. So that's it for the presentation. Again, we think that mass is a really, really exciting thing that's up and coming, and we really just want to see it succeed. So that's the purpose of this paper, is what can we do as people who understand. And we had a really, really great diverse background of academic backgrounds in this paper. So, we as people who understand transportation, or we as people who understand psychology really well, what can we inform mass apps on how to basically succeed? That's really the goal of this paper. So thank you so much for your attention today, and I think we'll move on to questions.
Thank you very much. It was a very interesting presentation, and also you finished just on time. So
excellent.
Is there any question? Geoff,
like
do you have access to the chat box?
I do, yes. Looks like there's a lot of questions. Okay, let's see. Independent discussion on the ticket. Yeah, so on mass, so I'm responding to Nathaniel's point on the business viability of mass, and that the profit margin is too narrow to interest investors. Yeah, so mass, like I cited in the presentation, there are some really high-profile private investors, But I do agree. I think that a lot of those investments are a little bit more speculative. They're saying this is an exciting idea, we should be paying attention. But I do agree. I think a lot of people look at this and go, you know, getting people to give up their cars for this, is this viable? Again, I think some of the points in the presentation can be used to address that. So I think getting people excited about mass, I think making sure that it's high profile and making sure that it seems like the next big thing, that's going to be really important. You know, we like to think that investors are extremely objective and extremely savvy, but at the end of the day, they are influenced by public perceptions. And if they think that the public finds something exciting, they're going to find it exciting as well. Disagree with the environmental part. So Nathaniel, you also made the point that with a carbon footprint tracker, that's really the only way to make an environmental signal, and that it might be better if users are rewarded for environmentally friendly decisions. I think that's a really cool suggestion, actually, because that would not only encourage them to be using mass and encouraging them to make more environmentally friendly behaviors, it would also be showing them, hey, look, you're doing a good thing for the environment, which is what we think is really important. We want people to feel good about what they're doing when they're using mass. So I think that's great. It not only sends the signal, it also gives them a reward. So it's kind of coming at it from two angles. Let's see. I'm just scanning for question marks right now. Let's see. Which institution am I from again? I'm from INSEAD. So we're a business school with technically four, but functionally, it's hard to describe, but we're a business school based in France with a large presence in Singapore as well. And that's the campus I'm based on. And we also have an Abu Dhabi campus, and we just opened up a, I think we're calling it a campus in San Francisco. It's mostly for executive education, but we're exclusively a business school. And I'm in the marketing department of INSEAD. Let's see, where's the mental health taking mass? With mental health features. Actually, I think that that's a really cool suggestion. So Yeow, could mass incorporate mental health aspects? I think that'd be really cool, actually. Yeah, that, I mean, it gets at kind of the crux of mass as well, which is it really is better for the consumer. You know, I think that sometimes when you're really talking about a product, it can get a little bit cynical because, you know, maybe you don't necessarily believe in the product that, you know, that you're doing research about. But I think we really do believe in mass because we think it's really good for the consumer. And yeah, incorporating mental health could absolutely be a part of it. It could essentially be taking that into account, saying, do you get stressed out being around major crowds? Okay, then let's try not to put you in, you know, this busy train stop. Do you, you know, again, you could do that with noise, or maybe it could be, you know, do certain types of days make you anxious? I mean, mass can incorporate that as well. So I think that's so important for mass, is making it as individualized as possible, really understanding the user, because that's what's so cool about it, is these apps are extraordinarily flexible. So they can really take things like your, you know, what mental health issues might you be dealing with, you know, on that serious end, all the way to more light things like what type of, you know, cityscapes you like to see. So it can incorporate all these things and then give you customized options. So that's really important for mass, and I think it's a really great suggestion. Thank you. Let's see. I don't see any more question marks, and it looks like I'm a couple minutes over my time, actually.
Thank you very much. Thank you very much for your presentation. Indeed, it was a very interesting presentation, and I guess too many people will be in touch with you for their questions. Mm-hmm. We will go to the next presentation. Milad will present investigating consumer preferences for driverless cars with a focus on media, commentary, and social influence. Elham, if you could please share your screen for Milad presentation.
Yeah, sure.
Milad, thank you. Milad is a lecturer at the School of Engineering and IT at UNSW Canberra. He's working on transport and land use planning, and his key research area focus on behavioral models and data analysis in the context of travel behavior, social influence, and subjective well-being. Milad has an extensive track record in engagement with industry and government, and his research is supported by Transport Canberra, Randwick City Council, Office of Environment and Heritage, and Australian Housing and Urban Research Institute. Milad, if you are ready, so please start your presentation. Sorry, Elham, start. and Milad will be available after the presentation for all the questions. Thank you.
Sure. Hi, everyone. Thank you very much, Massey, for the presentation. And thank you very much, Ellie, for sharing the recording of the presentation. I will be on the line, but unfortunately, I have some other commitments right at the same time, so I cannot present the research live. That's the reason we have the recording there, but I will be available for the QA session afterward. Thanks again.
No worries at all. That's the reason we are here, Milad. So Elham, if you could please share.
Yeah, awesome. All right, let me just share my screen. There we go.
Hi everyone, my name is Milad Ghasri. I'm a lecturer at UNSW Canberra at ADFA, and today I want to present my research on the impact of informational cues on preferences towards driverless cars and willingness to pay for automation. Before I start, I must acknowledge my co-author on this work, Associate Professor Akshay Vij from University of South Australia, for his significant contribution to this research. In this presentation, I will start by talking about the motivation of this research. Then I will talk about how we considered informational cues, how we collected the data for our study, the method we used to develop our models, and then the results we got from analyzing the models. And then I will summarize our findings in the conclusion section, and I will briefly talk about the limitations. We are all familiar with the technology of autonomous vehicles, vehicles that are capable of sensing their environment and operate without human involvement. And there is extensive research that shows this technology is going to change our transport system and travel behavior. While we all have our own opinion about autonomous vehicles, only a few of us have tried this technology. And whether we like it or not, this attitude, this favorable or unfavorable attitude towards autonomous vehicle is formed based on the informational cues we have received from external sources. In the literature of innovation diffusion, innovation decision process is known to have 5 stages. First, there is awareness, when potential adopters would realize this technology exists. Then we have persuasion, and that's where the attitude is going to be formed. And then we have decision-making stage, then implementation in real life, and then confirmation, where people will reconsider their decision and they will make another decision whether to continue with this innovation or whether to abandon that. In the literature of transport studies, we know that psychological constructs are integral to travel behavior, but this impact is usually studied at the decision-making stage. What we want to do is to examine the impact of informational cues on attitude formation, so at the persuasion stage and the decision-making stage. Humans are social species, and information plays a significant role in our life. Regarding the diffusion of innovations such as autonomous vehicles, information can create awareness, and they can also create favorable or unfavorable attitude towards the technology. In our study, we considered 4 different sources of informational cues, being mass media, social media, interpersonal communications, that is itself broken into positive word of mouth or negative word of mouth. And we also have market penetration, because autonomous vehicles can be considered as a conspicuous commodity, and other individuals in the society adopting to this technology can send out a confirmation signal that this technology is a trustworthy technology. We want to investigate whether the received informational cues from external sources can have an influence on the attitudes being formed towards this technology. To test this argument, we collected data using a stated preference survey. So our survey had 5 sections. We started by asking about media engagement habits. Then we had a name generator section where we asked our respondent to introduce 8 of their social contacts to us. Then we have a discrete choice experiment to elicit preferences towards autonomous vehicles. Then we directly ask our respondents about the quality of their relationship with the introduced social contacts. And finally, we collect some demographic attributes. What you see on this slide is a screenshot of the discrete choice experiment, the first part of the discrete choice experiment that we had designed. So what you see on the top table here is a hypothetical situation in terms of informational cues that has been received from external sources. Now, in this example, Andrew and Shane are actually 2 individuals, 2 of the social contacts that the respondent has introduced in the name generator section. Now, we would create these hypothetical situations where Andrew or Shane may or may not have already purchased autonomous vehicles, and they may or may not recommend it. Then we have sentiments from mass media and sentiments from social media. And we finally have the market penetration level. Now, what we ask our respondents to specify is that if that hypothetical situation is what would be realized in the future, then how likely or unlikely you are to consider autonomous vehicle, purchasing an autonomous vehicle. Then after this section is over, we reveal the second part of the survey. And in the second part of the survey, we have a vehicle choice experiment. So we present 4 different vehicles and we describe each vehicle using the salient attributes that they have. So body type, fuel type, driving range, etc., etc. And we ask our respondents to specify their preferred alternative. And finally, we ask our respondent how likely they are to actually purchase their preferred alternative if it was available in the market. We conducted this survey in December 2019, and we collected information from 862 residents from Sydney, Australia. We also checked the marginal distributions of our sample, and that closely matched the population distribution. However, I must mention that this data collection process was exogenous data collection. So even if there are small discrepancies between the marginal distribution of the sample with the population, the parameter estimates would not be biased. In this slide, I'm going to present the modeling framework in our study. So what we have right at the middle is AV consideration. That's a latent variable, and that is going to represent attitudes towards autonomous vehicles. In the discrete choice experiments we had in our survey, we directly asked our respondents to specify how likely they are to consider autonomous vehicles. So that question, the answer to that question, is going to be the measurement component for us to explain AV consideration. On the other hand, we have this structural component, and what we are trying to do is explaining AV consideration, that attitude, based on the external informational cues, so informational cues received from external sources. And what we have here is positive or negative word of mouth from AV owners or non-AV owners. We have sentiments from mass media and social media, and we have market penetration. Now, the feedback we receive from our social contacts really depends on how much we trust them. And that varies from person to person, right? So we also added this other latent variable, and we call that trust. And we assume that this is going to interact with how we process feedback received from external sources. Now, how do we measure trust? In our survey, we directly ask our respondents to specify how tech-savvy they find the social contacts they have introduced to us, or how likely they are to follow their advice or follow their decisions. But overall, we also wanted to explain this trust based on measurable variables that we have from social contacts, including demographic attributes of social contacts and the quality of the relationship between social contacts and the respondents. Then this AV consideration this is the hypothesis of our study, that this AV consideration would have an impact on the vehicle choice model. So the utility of vehicles not only is going to be a function of vehicle attributes, including body type, fuel type, etc., but also it is going to be a function of AV consideration in an additive form. This is what we considered in our model in this study. And then this utility is going to explain people's choice in terms of which vehicle they're going to select out of the presented 4 vehicle and how likely they are to purchase that vehicle. To capture the heterogeneity in taste, we used a latent class modeling approach. So we try to explain the heterogeneity based on the social demographic attributes of our respondents, including age, gender, etc. In order to determine the number of segments in our model, we went through an exploratory process by adding segments and monitoring the goodness of fit measures. And we ended up with an 11 class specification as our preferred model specification. I don't want to overwhelm you with the equations or the parameter estimates that we obtained from this modeling practice, but rather I want to focus on the findings and the results for the rest of my presentation. So if we consider the demographic attributes of our decision makers, of our respondents, what we found from our modeling practice is consistent with previous studies. We see younger individuals to be less concerned about adopting autonomous vehicles. We see higher education level to be correlated with higher tendencies towards autonomous vehicles. And we also see men are more open to this technology compared to women. However, the latent segmentation we had in our study showed a dominant male niche who will not consider autonomous vehicles regardless of informational cues. Regarding the trust component, one noticeable finding was that the coefficient for gender was significant in all 11 segments, and that was indicating that females are less trusted compared to males when it comes to autonomous vehicles by the sample of our study. We also realized that educated people and employed in full-time people are trusted more, family members are trusted more, and interactions on social media will increase trust. Regarding the structural component of AV consideration, what we found was informational cues were at least significant in one of the segments in our model, and that confirms the hypothesis in this study that informational cues have a significant impact on attitude formation. What we also realized is that social media sentiment has the largest positive effect for 90% of the sample, showing the significance of social media sentiments on AV attitude formation. A previous studies have shown that positive word of mouth on average has a greater effect compared to negative word of mouth, but the latent segmentation in our study shows that that impact varies across different segments, and we have segments in our sample where negative word of mouth would have a higher effect compared to positive word of mouth. And we also showed that depending on whether the social contact is an AV owner or a non-AV owner, the feedback and its impact would be different. We then used our model to calculate market elasticity of demand for vehicle attributes. Elasticity is defined as the percentage change of AV demand in response to 1% change in the independent variables. In our modeling framework, we have vehicle utility being formulated as a function of vehicle attributes. So we did a sample enumeration, and what we did there was changing the continuous variables by 1%, one by one, and investigating its impact on the change in demand for autonomous vehicles. And for binary variables, we switched them to 0 and 1 and checked its impact on, again, the demand for autonomous vehicles. And what you see on the right side of this slide is the distribution of elasticity in our sample. So for example, if I look at purchase price, These bars shows the percentage of our sample having, the horizontal axis is the elasticity, and the vertical axis is the portion in the sample with that elasticity. So that's distribution of that. And you see there is a wide distribution for purchase price. It's always negative, the elasticity is negative, but the distribution is wide. As another example, you can look at running costs, and again, the elasticity is always negative there, but the distribution is narrower relative to purchase price, for example. We also had some interesting observation, for example, regarding fuel type being battery electric vehicle. We see a bimodal distribution here. So some people having positive elasticity towards battery electric vehicles, and some people having a negative sensitivity towards this attribute. All previous studies where a vehicle choice model is developed and the utility of vehicle is a function of vehicle attributes, in principle can be used to calculate market elasticity for vehicle attributes. What is unique in this study is that we can also calculate market elasticity of demand for informational cues. Now remember, vehicle utility in our study is not only a function of vehicle attributes, but it's also a function of AV concentration. And AV concentration is a function of informational cues. So the enumeration practice that we did in the previous slide in order to calculate elasticities towards vehicle attributes, we can repeat the same process, but this time we can calculate elasticities for informational cues. Now, the histograms that you see on this slide shows elasticity for informational cues. And what we realized is that, for example, elasticity towards word of mouth, it is significant on average, but there is a heterogeneity across the sample. So for example, look at negative word of mouth from AV owners. We have respondents who are being sensitive towards that and having showing high elasticity towards that. But we also have respondents who are not as sensitive towards negative word of mouth. On average, we also realize that mass media sentiment has a higher impact compared to social media sentiments. We can go beyond and we can calculate the impact of informational cues on willingness to pay for automation. Now, willingness to pay is defined as the marginal utility of automation over the marginal utility of price. If automation is considered as a binary variable in the model, then this willingness to pay would simply, and the utility function is linear, then this willingness to pay will simply be the coefficient for that constant over the coefficient for price. But in our study, utility of automation would depend on AV concentration, and AV concentration is a function of informational cues. So willingness to pay will become a function of informational cues. And what you see in this table is the impact from each of these informational cues on willingness to pay. So for example, for market penetration, and this is calculated for 1% change in market penetration, the impact on willingness to pay is going to be $650. 1% increase in mass media sentiments will result in nearly $400 increase in willingness to pay for automation. Regarding word of mouth from AV owners or non-AV owners, we did the calculation for an average trusted social contact. And what we show is, for example, a positive word of mouth from a non-AV owner can have a significant impact equivalent to 14,000 increase in willingness to pay for automation. To wrap up, our result confirmed a significant impact from informational cues on persuasions towards AVs. We showed that social media sentiment has the largest positive effect on AV consideration for 90% of our sample. We showed that family members are trusted more. We showed that men, those with full-time job and college education, are trusted more. We also showed that willingness to pay doesn't need to be a constant value. It can vary depending on the received sentiments and word of mouth from social contacts. And we showed that the impact can be significant. Regarding the limitations of this study, we accounted for trust associated with social contacts, but we didn't consider trust with other sources. Also, we considered social media to be independent and in parallel to mass media and interpersonal communications, whereas social media can have some overlap with the other two. We also used stated preference survey to collect the data, but attitude formation is not instantaneous. So perhaps a more reliable source of data can be used to investigate the hypothesis of this study. And finally, when an initial attitude is formed, then that can act as a barricade in processing further information. And this is something that is not directly considered in this study. This concludes my presentation. Thank you very much for your attention. And please let me know if there is any question.
Thank you very much for the
My
presentation,
name is
Milad.
Ghansri. I'm a lecturer at UNSW Canberra at ADFA. And
Sorry. Thank you very much for the presentation. Is there any question?
Yes, sorry, I had a question about the quotas. I forgot where, I mean, I missed that part when you explained about the sample size and how did you get the quotas from different populations. So was it based on the gender, age, and other social demographic, or just these two, and what was the source? And yeah, so where were the respondents from?
Yeah, sure, no worries. Thank you, Ellie, for the question. We used the assistance from the market research company to do the data collection for this study. We collected data for more than 800 residents in Sydney, and the quotas we had there was based on gender, income, and age. But on top of that, we also checked the marginal distribution for employment, being full-time, part-time, not engaged, education, household structure, household vehicle ownership, dwelling type, tenure type, and yeah, I'm just having a look at my list here. Yeah, and that's pretty much all the variables that I checked the marginal distribution between the sample collected and the population. Overall, we have a close match, but the point that I was trying to make there was, because we are doing exogenous sampling here, even any discrepancies between these marginal distributions wouldn't cause the parameter estimates to be biased in any means. It's just that whatever we conclude from the simulation of our models, when it comes to extending to the population, we need to adjust according to the differences between marginal distribution. So we need to include weights when we extend our findings to the population, if that makes sense.
Yes, of course. Yeah, thank you, Milad, for explanation. I just asked because we did a study on solo, pooled, and also autonomous-based ride-hailing services in 5 states: Queensland, Western Australia, South Australia. So we actually excluded New South Wales and Victoria. And for instance, for the autonomous-based ride-hailing, then women or female individuals were more likely to use such services. So I found that contradiction between definitely it's ride-hailing is different and also different state. But that was interesting, just that.
Oh yeah, absolutely. I mean, the findings in the literature is kind of mixed. So some studies shows men are more inclined towards this technology. Some shows women are more inclined, and that obviously depends on where the survey is being conducted. What are the actual questions, and at what time is this survey being conducted? Because the information about this technology that we receive is changing on a day-to-day basis. So we are getting updated, I would say, on a daily basis. And I think the point that I was trying to make is that, yes, on average in our sample, men are more open to this technology, but the latent segmentation practice shows actually we have female cohorts who are more open compared to men. And we also have men who are really adamant of not considering autonomous vehicles, regardless of what are the informational cues that they're receiving externally. So they show pretty much deterministic behavior in our sample. And yeah, totally, we have mixed findings in the literature. So I really didn't want to imply that men are more open to this technology.
No.
Yeah, there is.
No. Yeah, definitely there's a dichotomy in terms of those social demographic attributes. And again, as I said, our study was more on autonomous-based ride-hailing services, which might be different from ownership of autonomous vehicles.
Yeah, absolutely.
Thank you.
No worries.
Milad, we've got some questions in the chat box. So we have 2 minutes to finish up this session. Please have a look on the questions and answer as much as you can.
Oh, yeah, sure. Okay. Okay, so I see a question from Niraj. Hi, Niraj.
Hey, Milad, my old friend from UNSW.
Yeah, it's really nice to see you here. So
Likewise.
The question is, Agent Under.
I can say that while I had a couple of questions, maybe in the interest of time, I'll just ask the more relevant one.
Sure.
The WTPs which you showed, they are very interesting, very promising as well. So have you looked at some form of validation, whether the obtained WPs, the dollar values are inconsistent with some theories? Because these WPs would be very beneficial when it comes to policy making, or even for practitioners when they use such parameters for some kind of economic assessment?
Yeah, absolutely. So in terms of validation, I would say, let me explain it in this way. I had a look at the literature to see what are the willingness to pay values reported in previous studies. And then when I wanted to compare these values with what I have in this study, there is not an apple-to-apple comparison. The reason being is I don't have a constant willingness to pay from this modeling practice. The willingness to pay values in this study can be anything depending on how do you define your informational cues status. So the values that I presented in the table are not the actual value of willingness to pay. It's the incremental change in willingness to pay given 1% change in the sentiments you are receiving from mass media, social media, or given you are receiving a positive or negative feedback from your social contacts. So in a way, what I'm trying to say is that when we design our stated preference surveys, or when we develop our choice models, the outcome of that, when it's interpreted in terms of willingness to pay, it's either a constant value or a constant distribution, depending on whether we consider taste heterogeneity or not. But that constant value will not change. What is different in our study is that marginal utility for automation is a function of informational cues. So there is no constant willingness to pay. And then, so what I did in terms of validation, again, there is no direct comparison, but what I did was just trying to start with some reasonable assumptions in terms of sentiments from social media and mass media, or positive or negative feedback from social contacts, and see what is the willingness to pay that I get, and whether that value is within the range of reported willingness to pay in previous studies. If you check the paper, you can see a whole discussion on this topic there. I'm quoting a few of the previous researches, and I'm showing that under what status of social media, mass media sentiments, we can match this willingness to pay. But again, I think the short answer to your question is, I am giving 1 degree of freedom to this willingness to pay. So anything that you find from previous studies, I can match that by just reverse engineering the informational cue status.
Sounds good. Definitely, I think that helps, Milad. Thank you so much.
Yeah, no worries. And Niraj, I saw you had another question regarding age being included.
Maybe you can leave that and take another question by Nathaniel. That's fine.
Yeah, sure.
I can always touch base with you offline.
Yeah, no worries. No, we didn't consider whether the vehicles will be operated in shared mode or connected mode. All we had in our study was autonomous vehicles versus legacy vehicles. And yes, point taken, but let me just reiterate the contribution of the study. It's not really the autonomous vehicle that is the focus here. The study can be conducted for any innovation in transport. The idea is we have these informations being broadcasted and being discussed in the society, and how is that going to have an impact on how we see these technologies, and trying to quantify that using a stated preference survey. So autonomous vehicle was one example, but we can repeat the same study for any other innovation. And I think that's pretty much all of the questions in the chat box. I don't know if I have time, maybe I can quickly cover Niraj's question as well.
Yes, please.
Yeah, sure. So regarding the question of having age and gender both in the class membership function and in the structural level, if you check the platform, you see age and gender there, but age and gender in the class membership function, that is age and gender for the respondents. But age and gender in the structural component, that's age and gender for the social contexts that respondents are introducing. In other words, we are trying to say, the way I trust my social context would depend on the demographic attributes of the social context. So I may take advice from my younger social contacts more seriously compared to older people when it comes to autonomous vehicles, because I might have this internal belief that younger people are more tech savvy, or I may find more educated, so my educated social contacts more reliable in terms of the advice that they are giving to me regarding innovations such as autonomous vehicles, more compared to less educated individuals. So that trust component that we have there, the structural part is trying to, the demographics of social context is used to explain that trust component. But at a higher level, we have demographic attributes of respondents to help us segregate different segments in our sample. So I think correlation would not be an issue here.
By looking at just age or gender, I just got mixed up that probably it's the same variable which is being talked about in the slides. That's good, Milad. I just had one more question, if I may be allowed to ask.
Yeah, but I'm more than happy to answer. I'm not sure.
So maybe if Macy can let me know if it's
yeah,
okay
go ahead, go ahead.
Milad, definitely the class membership model identified 11 segments, which is, I do see that from a statistical goodness of it standpoint, yes, we would have you would have checked different number of segments, and this would have been the best statistically. But from a policy standpoint, do you see that policymakers would find it more convenient to have fewer segments rather than 11, which in my opinion is slightly on a higher side?
Yeah, that is actually a very good question, Niraj. So being honest, we had a very long conversation I had a very long conversation with Vij regarding how to decide about number of segments here. And this is what we both agreed on. So when we are going with the latent class model, the segments are not really representing distinct individuals. So we don't have anybody fully belonging to one of these segments and not belonging to any other segments. These are really mass points, right? So, so whether to go, like how many segments we get there, I think that is driven based on the goodness of it measures. But how are we going to present it so that it is helpful for policymakers and those who are not really familiar with the statistical aspects of this modeling was a challenge. And that's the reason actually I'm not presenting any of these tables, any of the parameter estimates or any individual classes there, but rather I'm presenting aggregated measures of elasticities or willingness to pace. And in a way, I think I'm trespassing the boundaries of traditional latent class modelings and the interpretations that we have there and moving towards more data-driven modeling approaches where we say, well, we have a distribution for our parameters rather than a fixed number. And this distribution in this latent class modeling is assumed to be a discrete distribution. But how many classes do we have there? I'm just gonna let the data guide me on that. But then after identifying these 11 classes, I'm not trying to justify that they are really 11 distinct classes and people will belong to each one of them and not belong to any other one of these classes in this method. Rather, I would say, well, this is just a discrete distribution of taste heterogeneity towards different attributes. And then I will just try to simplify the way I'm presenting my findings by presenting willingness to pay and market elasticity measures, if that makes sense.
Yep. So just if I understood it right, what you're saying is you use data to actually drive the number of segments and not just exogenously testing that which number of latent segment gives you the best model fit?
Oh, no, that's exactly what I'm doing. But that's a data-driven approach, isn't it? Because you are manually adding one segment and you're checking the goodness of fit.
Right, but of course, that is something which I feel as an analyst, I'm just testing out which is the optimal number of latent segments. But after that, we try to back it up, whether our data shows an evidence of those 11 latent segments or not. That is what my understanding has been, that we first figure out what are the optimal number of latent segments, and then we go back and see whether our data can actually testify whether these segments do exist in our current data set or not.
So that is the part that I'm actually saying I'm probably not going with the convention. So is it really necessary to check whether all these 11 segments are meaningful or not? I mean, what is a data-driven behavior here? If you wanted to do it, instead of doing a classic econometrics model, you wanted to go with the data-driven approach, all you would be doing is just saying, well, this is my data, give me the best fit. And this is pretty much what I'm doing here, but in a more structured way, borrowed from econometrics literature. So I wouldn't be really picky about having 11 distinct classes regarding their behavior. Yes, I did check them and I did make sure that, well, having these 11 classes makes sense to me, but this is not the part that I would be emphasizing on discrete, on latent class modeling, if that makes sense.
Good. Sounds good. Thanks, Milad.
Yeah, not a problem.
Thank you very much, Milad, for the presentation and for answering all the questions. If there is any other question, please feel free to get in touch with Milad. We had so far 4 interesting presentations in this session, and we will end this session now. I hope that you enjoy the rest of the conference. Thank you.
Yes, please don't forget tuning for tomorrow's sessions. They're going to be very interesting ones.
Thank you, everybody.
Sure. Thanks, everybody.
Thanks, everyone. Bye.
Bye.
Bye.